This is a production of Cornell University.
Lately, the last year or so in New York, there's been some, buzz about seed treatments. So we asked Jeanette to come talk today. Jeanette has been with the New York State Pesticide Product Registration Program for over 30 years and has handled all types of pesticide registration activities. So she is here today to talk to us about neonicotinoids and the future of seed treatments in New York. So Jeanette.
Hello, everyone. So I do have quite a few slides. I'm going to go through this kind of fast, but there's a lot of things that we really have to discuss as to what's going on with seed treatments in New York State. Okay, so just briefly, what neonicotinoids are. It's a class of insecticides chemically related to nicotine. It includes acetamiprid, clothianidin, dinotefuran, imidacloprid, and thiamethoxam. And they're especially effective against sucking and chewing insects such as aphids, white flies, and there's also bed bugs and fleas. It's a big pet products too for imidacloprid and dinotefuran. Okay, sure. It's also used in a range of different products. Indoor insect control is big, ag, greenhouse, and of course there's the seed treatments. So many of these active ingredients are registered with various use restrictions which limit the outdoor exposure. For example, dinotefuran is limited to crack and crevice or spot treatments, and there's some SLN registrations that have been allowed for limited use, mainly for direct application to like tree trunks for invasive species. Clothianidin is registered for indoor use only, and seed treatment products are not registered in New York State. So the way it works for the pesticide registration are all products have to be registered in order to be sold, offered for sale, distributed, or used in the state. The application of the seed treatment pesticide product to the seeds is considered the use. So for clothianidin, you cannot do that in New York State. However, as long as the seeds are treated by pesticide products that are legally registered in whatever state they're being applied in, they can be shipped into New York State and planted. So that brings us to the legislation. There seems to be concern that we are not regulating those seed treatments because, for example, clothianidin can be used for seed treatments, but we specifically did not register it. So there's proposed legislation. It has been referred to as the Birds and Bees Protection Act. This year it did pass the Assembly and the Senate and almost made it through the Senate, but we do expect it to come back next year. And it would add a section to the ECL, the Environmental Conservation Law, under Article 33, Title 13, Unlawful Acts. So the proposed language of the legislation would make it unlawful for any person to sell, offer for sale, or distribute any corn, soybean, or wheat seeds coated or treated with pesticides containing clothianidin, imidacloprid, thiamethoxam, dinotefuran, or acetamiprid. And the proposed legislation had a date of January 1st of 2025, but since it didn't get approved, that date would change when they do the new legislation. So in order to allow use, there's only specific provisions, and I'm not going to read all through this, but so it would only be under direct consultation with DEC and Ag and Markets, and they have to issue an executive order determining that there's a lack of commercially available untreated seeds or that compliance would result in undue hardship. And then they would do a temporary suspension of the prohibition, and you'd have to specify the time frame and the type of seed, and it'd be a very limited time frame. There's also additional provisions, and it's going after no person shall apply or treat outdoor ornamental plants and turf, except for the production of an agricultural commodity. And that is for imidacloprid, thiamethoxam, or acetamiprid on or after July 1st of 2024. And again, since this didn't go through, that date will be changed when they do propose new legislation. And we assume that they're going to have some type of the same provisions in the next go around. They also had in there that the active ingredients clothianidin and dinotefuran would be effective immediately. And they do have some exceptions for environmental emergency. And then again, our department would have to consult with Ag and Markets and determine, justify with a detailed order that there's a valid environmental emergency. The pesticide would be effective in addressing the environmental emergency and no other product can be used. So it's very limited. They're trying to really cut down on the use of the neonics. So they're limiting it with like I said, it would only be 6 months. So it's not like, yeah, we're going to allow this. Yeah, we said there's an emergency, but it's only gonna be for 6 months. So it's really, they're tightening the noose on the neonics. They do have an environmental emergency definition in the legislation, and it's right up there. But so it's very specific. And in order to do the emergency declaration, we would have to be very specific, and it would have to be, it would be an official thing with our department in Ag and Markets. So why are they doing this? There's a big desire to prohibit the use of neonic treated seeds and certain neonic products used for non-ag purposes. There's various reports regarding the limited benefits of using treated seeds versus the risk to pollinators. They're saying that the risk to pollinators outweighs the benefits. The seed treatment pesticide products are registered, but as I said before, the pesticide treated seeds are not registered. And we as in the Department of Environmental Conservation do not regulate treated seed. So there's NRDC and other groups want treated seeds to be regulated as pesticide products. And, there's various concerns. There's lots of reports and so on about the use of neonics and, what they do to surface waters and pollinators and so on. So we are being urged to do more things to protect pollinators. The issue is very complex and there are very many factors which impact pollinator health. I mean, there's, genetic diversity, there's, monocultures and so on. And there's also, the varroa mites and so on with bees and pesticides. I mean, sure, there's pesticides too. But pesticides are very easy targets. They're already very heavily regulated, and the neonic treated seeds are considered a loophole. So in April of 2017, a group of beekeepers and farmers and NGOs, NRDC, submitted a petition to EPA, and they requested that EPA amend or formally reinterpret the treated article exemption so that it does not apply to treated seeds. They also asked EPA to declare that pesticide treated seed is subject to regulation under FIFRA as a pesticide. And this is huge. This is absolutely huge. So just, this is the treated article definition. So when I think of a treated article, I think of a shower curtain. They treat the shower curtain so it doesn't get mold and mildew on it. There's also like telephone poles are treated, but you don't register a telephone pole, you register what it was used to treat the pole. Just like shopping carts, you see all the microban stuff, that's considered a treated article. So the petition claimed that EPA did not adequately assess the risks from the use of seeds, of the seed treatment pesticides that have systemic properties, and the use of seeds themselves that have been treated with the pesticides. So there's a concern that the use of the treated seeds are causing a problem because you don't know what that is doing to the environment, just using that treated seed. And they also claim that the treated article exemption may not cover treated seed without an adequate assessment of the risks. So EPA did respond the end of September. They did not agree with the petition as to the treated article exemption, and they will not grant the petition request to either, reinterpret or amend the regulatory text for the exemption to exclude seed treated with systemic pesticides. But EPA did agree with the petitioner's concerns on clearly communicating the labeling instructions to the users of the treating pesticide and the treated seed. So as you were saying before, they were going after the labeling for treated seeds. This kind of goes along with that there's concerns that there's a big gap between the pesticides that are used to treat the seeds and how the label on this treated seed is. So they're saying that there's a gap there and they want to focus on that. So EPA has been reviewing labeling instructions for pesticides registered for seed treatment uses and making sure that those instructions are correct. And there's complete and appropriate instructions for the distribution, sale, and use of both the treating pesticide and the treating seed. So that would be like the seed tag labeling. Also, EPA said they intend to issue an advance notice of proposed rulemaking to seek additional information on whether or to what extent pesticide-treated seed is being distributed, sold, or used in a manner inconsistent with treating pesticide labeling. So they're trying to figure out if everybody's doing what they're supposed to be doing. And they're going to consider appropriate actions if they find that there's problems. Also, the more concerning, as part of the advance notice of proposed rulemaking, EPA will also explore the option of issuing a rule pursuant to FIFRA Section 3A to regulate pesticide-treated seed to make sure that it's consistent with treating pesticide and treated seed labeling. So this would change how seeds are regulated. Pesticide-treated seeds would be regulated differently than non-treated seeds. I mean, if you think about this, it's kind of like, I don't even know how they would do this. I've been in this program for, over 30 years. I always thought of seeds as an agricultural commodity. I don't think of them as a treated article. I just think of them as separate. So, they're trying to pull them into some sort of regulation, and they want them regulated as pesticides. So right now, seeds are regulated by USDA in accordance with the Federal Seed Act. In New York State, the Department of Ag and Markets regulates seeds in the state, and they would be the ones that would go out and get a package of something and test it and make sure. Now, the proposed legislation that we had in New York State would add provisions to the ECL to regulate seeds, but there's nothing in the environmental conservation law regarding seeds. We don't regulate seeds, so I don't know how we would even do that. And I've said that before. It's like, how are we going to do that? Oh, you just do it. It's like, well, they're not pesticides. How are you going to register them? Who's going to register them? Is it going to be on the farmer to register them? Is it going to be on who's treating them to register? And when you register a pesticide product now, there's labeling involved. Somebody has to label the product. There's a number involved. There's all of the registrations that they have to do. They have to send it to the department. They have to pay for it. Somebody has to label it. There's all kinds of tracking and chains and so on. I don't even know how that would work. I quite honestly, it's like, I have no idea how they're going to do this. And as I said, the latest EPA proposal is going to explore options on how to regulate treated seed in accordance with FIFRA as a pesticide. I just don't know how they're going to do that. You're going to change, so you're going to have non-treated seeds and then treated seeds, and they're going to be regulated in a different way. I just don't know. I don't know how they're going to work that out. So, we have many states that are taking actions against neonics. We have, Massachusetts, Maine, Maryland, Wisconsin, they're restricting neonics and they're banning consumer use. And this is not just seed treatment products, but it's consumer products. The thought for consumer products is that consumers aren't as careful and they don't read the labels as well as a certified applicator or someone who is trained. So that's why a lot of times the restrictions go after the consumer products. And they think that the use of these products are more for aesthetics and that you really don't need it. You just want a beautiful lawn or you just want your beautiful flowers. In Connecticut, they're doing certain neonic use patterns, classifying as restricted use, and they have different guidelines for seed treatments. Oregon prohibits the use of neonics on linden trees, and that had to do with there was a huge bee kill. Somebody sprayed a tree, I think it was like in a Target parking lot, and they killed 80,000 bumblebees or something. It was really ridiculous. So, I mean, it brought to the attention that, yeah, well, it's an insecticide, so it's going to kill bees, but the bees were right there. And Vermont, it's very difficult to figure out exactly what Vermont is doing, but outdoor use of neonics are classified as restricted use, and they require the reporting of treated article seed and quantity of untreated seed sold. So, they keep talking about neonics and seed treatment, but where's it going to stop? Is it going to go to other non-neonic products that treat seed? I mean, we have tons of fungicides that are used on seeds. I mean, where's it going to stop? Who's going to say, oh, it's only those and it's not those? It's going to be very difficult to carve out. So what is New York State doing? Because we have received criticism for not doing enough regarding the use of neonics in the state. We get called to just ban it. Why are you allowing it? You don't need it. The proposed legislation will force additional provisions to decrease or eliminate the use of neonics, but that's not really the way we want to do it. We want it to go back to our pesticide program. So we decided one of the easiest things we can do to show that we're doing something is to reclassify some of the neonic products as restricted use. And that goes along with other states. At least it's like, well, yeah, New York State is doing, the same thing as, Connecticut or whoever. So pesticide products containing imidacloprid, acetamiprid, or thiamethoxam that are labeled for foliar or widespread outdoor use or seed treatment will be reclassified as restricted use, and that's effective January 1st of 2023. And we've told the registrants way in advance about this. So hopefully the news has trickled down. So there's 27 imidacloprid products and 23 thiamethoxam seed treatment products that will be restricted. So what that means is that in order to get one of these neonic products to treat your seeds, you either have to be a commercial applicator or have a commercial permit to sell it and so on. So, but there's really not that many that I know of commercial seed treaters in New York State. That's what I've been told. Correct me if I'm wrong, but I don't know the impacts to people in this room or the seed people who use treated seed in New York State. The registrants did not indicate that it was going to be a huge problem. They didn't really blink an eye, actually. So I don't know if they actually told people about it and don't know anything, or it's not really that big of a deal. So neonic products that are labeled for limited ground application directly to the base of trees, shrubs, and plants are not included in this reclassification. So there are a few products that are not going to be restricted. So Jan, I wanted to add this for you. So what else we're doing in New York State is the Department of Ag and Markets is also looking at seed treatments because they are the ones that regulate treated seed. And they recognize that seed treatments are a valuable tool for the ag industry, but their current authority only provides the ability to require labeling on treated seed if the treatments pose a threat to human health or other vertebrates in the quantities used. And that's how their regulations and their laws are written. And that's like mercury compounds. These are very old laws. So they're thinking about doing changing their laws so that it can enable the ag and markets to also label treated seeds for environmental concerns, considerations such as water quality and off-target organisms like pollinators. So the thought was maybe having a supplemental label that you didn't have to necessarily attach to the container or a bag, but say if you have a bag of seeds with clothianidin treated seeds, you would have a supplemental label that had best management practices and so on about it. But this was a proposal last year. I don't know, they're tweaking it, everything's changing. So I don't know what the new one's going to be next year. Scott Menrath, my supervisor, was like, well, it might change. I go, well, I'm going to say that they're doing something. I don't know exactly if it's going to be this, it's going to be something else. But the whole goal is to allow the department to require some sort of labeling so that you can kind of keep it going and you're not going to lose it. So, best management practices and, getting the word out to the end user is what they're kind of looking for. And our goal as a state, as regulators, is to be able to maintain the use of pesticides that are needed for the critical uses while minimizing the impacts to human health and the environment. And that includes the pollinators and other non-target organisms. We have to have ample tools in the toolbox because there's always another invasive species coming up. It seems like there's always these weird things coming in. You have the, emerald ash borers and the Asian longhorn beetles, and there's always a new, something or other coming. And we want to avoid resistance. You want to switch from one to another. You don't want to rely on one certain class or one certain product. So what can we do? We try to respond with sound science, and it's very difficult with the internet. We always hear this, there's this study saying that, it's killing deer. Imidacloprid is killing deer. And you're like, we showed that study to our ecotoxicologist. He goes, that's a really bad study. It's like, yeah, but trying to get that information back to, the people in the legislature that are looking at that study and like, oh my God, it's killing deer. We have to hurry up and do something. So, it's very difficult. There's a lot of misinformation out there, and trying to get the right information out there is very, very difficult. And it's very important for them to know that the amount of pesticide used for seed treatment is less than using multiple post-plant applications. They don't realize that, seed treatments are actually, you're using less. And it also has to do with favorable planting and cultivation techniques. There's a lot of things that, go in conjunction with treated seeds. And we also want to highlight and promote best management practices and integrated pest management, because that is really the way to go. That is the best way. And a lot of times when I'm talking to some of the people or executives, I said, farmers just aren't throwing pesticides out willy-nilly. I said, they're working on very thin margins. You're trying to do the, what you can with, what you have, and trying not to spend a lot. You're not trying not to get out in the field 10 times because that's very expensive. So, you're trying to limit, the resources that you expend. And they're like, oh, we never thought of it that way. It's like, oh. So it's very difficult trying to get that information out there. Questions? Yes.
What's been the big thing that's come out now is overtreated corn, things like that, the biological, but you're going to be handling the product that's already been treated with neonic stuff. How do those things get regulated?
That's a good question. I mean, a lot of times when we get biologicals coming in, if it's a pesticide, we might know about it. If it's not a pesticide, we don't even know. So, that might be something that would have to go on the treated seed labeling. You get the seed bag, say, if this contains, whatever, if you're handling it again to put more stuff on it, you make sure you're using the correct PPE and so on. It's a good question. I don't know. And a lot of times for the biologicals, for the biopesticides, EPA is sometimes they think, well, it's a biopesticide. It's all right. But we review it, and there's a lot of lack of data as to, for non-targets and things like that. So there's some data gaps for biopesticides. But I don't know, further handling of treated seed to apply something else. I don't even know how the biologicals would work with, like insecticides on it. They're gonna have some sort of, I don't know, some combination and do something. I don't know. Anybody? Yes.
Am I correct that the sale of a unit treated seed to a farmer is not the sale of a product?
Correct. Correct. Because the product, the bucket, the jug is the restricted product. So once you apply it to the seed, it's no longer considered a pesticide product. And that's the nut that the legislature is trying to crack. Any other questions? Yes.
One of the beginning talk you mentioned, harmonize. I thought anytime we treated seed, we had to be commercial license regardless if you were using non-restricted things. But you said before, when you said at the beginning, that made it sound like the path, you didn't have to have it.
Well, I believe if you're like a farmer using, like if you're just doing a general pesticide application on your farm, you don't have to be certified. But if you're a commercial seed treater working wherever doing the seeds as your business, yeah, you would have to be certified. And then using a restricted product, there's other things that you have to do. There's the reporting and so on. There's a whole chain of custody type of thing for that. But anybody else? Yes. Well, in general, if you use treated seeds, then there wouldn't be needs for, a lot of other things. I'm sure there's other products that are used after that, but in general, there would be less. So that's the thing. They're focusing on neonics. It's like, yeah, but if you get rid of this, then you're going to use, 10 more of this over here, and that might not be what you want either. So it's very complicated. Well, thank you very much.
All right, thanks, Janine. Again, neonics have kind of been the buzzword the last few years here in New York. NISABA and the board has definitely taken their time and gone out to legislator and talked to them. So if anyone is interested, please talk to those who are on the NISABA board more about this. Most of us will be around through lunch, and I don't know if Janine will be around if you want to talk a little bit more about it. Our next speaker with us, again on Zoom here, is Gary Munkvold. He is a professor of plant pathology at the Iowa State University Seed Center. He is the chair of the ISU Graduate Program in Seed Technology and Business, and is a co-director for the administrative unit of the U.S. National Seed Health System, a collaborative public and private program whose mission is to facilitate U.S. seed exports through research, method standardization, and accreditation related to phytosanitary testing and inspection procedures. So with us today, he is going to talk about seed health and harmonizing testing methods.
All right, well, good morning, everybody. I'm happy to have the opportunity to share with you this morning some of the work we do here at the Iowa State Seed Science Center, and I'll also be talking about some other programs that have similar goals to what we do with the National Seed Health System. And I chose the title about collaboration because I really want to emphasize how important that is in the whole space of seed health and particularly with the international movement of seeds, which is so critical for today's seed industry to operate, even when we're talking about seeds that are sold domestically. It's very likely that in the course of the development of those varieties of seeds that the international shipment of seeds was involved. So this is something that really is critical for the seed industry to operate the way it does today. And it really does require collaboration among a lot of different stakeholders to make sure that the seeds that we plant are not responsible for spreading pests and diseases. There are a lot of stakeholders involved who collaborate in these efforts. And this slide has plenty of acronyms, which I will, some of which I'll elaborate on, and others you can follow up later if you like. But we can put these stakeholders into some different categories. We have the plant protection organizations, which are at either the national or regional level. So here in the United States, it's USDA APHIS. We have the North American Plant Protection Organization, the European Plant Protection Organization, and there are other regional organizations around the globe. We also have plant protection agencies within the states that are also participating. Then there is another category of what I would call official national organizations, which are semi-governmental. So the National Seed Health System would fall into that category. So that's the program that we administer here from the Iowa State Seed Science Center. And it is a collaboration between us and USDA APHIS and the seed industry. And you'll hear a lot more about that as I progress. Another example, Jeanette is a similar type of organization in France. And then now is also an analogous organization in the Netherlands, which also has a global reach due to the importance of the Netherlands in the global seed industry. And of course, the seed industry itself is a very important collaborator. There are a couple of specific organizations. You have the International Seed Federation, which operates the ISHI program, which is the International Seed Health Initiative, which focuses very heavily on vegetable crops and developing seed health testing methods for vegetable crops. The American Seed Trade Association, I've already mentioned, is a key player in the national seed health system, but also is involved in helping the seed industry with many of the phytosanitary issues that pop up on a seemingly daily basis when it comes to moving seeds internationally. And of course, around the world, there are other national seed industry associations that are analogous to Asst. And then there are many individual companies that participate heavily in developing and validating seed health testing methods, either under the umbrella of ISHI or in collaboration with NSHS, or in collaboration with other organizations like NAPO. And then on the international global scale, you have the International Plant Protection Convention and the International Seed Testing Association. And on the slide here, the few programs that I've shown in bold are the ones that I'm planning to talk to you about in a little bit more detail today. So there are a lot of challenges when it comes to seed health testing, and the top one, I think we have to agree, is the issue of emerging pathogens. There are a number of examples right now, like the tomato brown rugose fruit virus, posmiviroids in tomatoes and peppers, high plains virus in corn, maize chlorotic mottle virus, another corn pathogen. And these pathogens, when they do emerge, they tend to become a regulatory issue much more quickly than the scientific community is able to adapt to them in terms of being able to come up with effective, validated testing methods and management practices that are designed to deal with pathogens that we don't have experience with. So that's a really big challenge. And right along with that comes the phytosanitary regulations, which are always changing. Some of those changes are in response to emerging pathogens, but others are in response to other forces that may or may not have a scientific basis. And those changing regulations are very difficult, again, to adapt to on the fly when we're shipping so many shipments of seeds internationally. Just as an example of that, the volume of international seed shipments continues to grow. In the APHIS annual report, they reported that they approved 703,000 phytosanitary certificates in the year 2021. That does not include the ones that may have not been approved because of problems that were with the applications. And then you have a capacity issue with the seed health testing system and the labs that are involved. Especially when there are new regulations that require a great deal of extra testing, it's not that easy to scale up immediately in the public labs or even within the companies to be able to provide the throughput necessary for and increased demand for testing. Public facilities, as always, have limited resources, and those resources are not elastic in response to the emerging issues that come up for seed testing. And then, of course, one of the things that we focus on and try to continuously try to resolve is the lack of agreement on best testing methods among trading partners. And so that's gets to the harmonization issue, which is something that we continue to work toward, but it's always kind of a 2 steps forward, 1 step back kind of procedure. And you know, there are a lot of different opinions. And as a sort of a component of that lack of agreement is this issue about the biological relevance of testing results. When you test seeds for pathogens, and if you have a positive result, does that, in what extent does that really indicate the risk of a disease outbreak occurring when you plant those seeds? And this is becoming more and more acute because of the fact that we have more and more sensitive testing methods, which are capable of detecting very low levels of contamination or components of a pathogen, which are detected in terms of either proteins or nucleic acids, which don't necessarily tell us that that pathogen is viable or able to cause disease. And then on the regulatory side, we know that not all regulations are based on science, so we continue to try to inject science into the regulatory systems that we deal with around the world. Just to give you a little bit more background on the scope of the challenge, if we look at bacteria, for example, that are regulated in terms of seed trade, the International Seed Federation has a pest list that includes 15 vegetable crops or crop groups, and on their list, they indicate that they have data about 184 bacterial host combinations that are subject to phytosanitary regulations. But of those 184, according to the literature reviews that they've done, only 28 of those have definite evidence for which seed is a pathway. And then there are 19 additional ones for which the evidence is equivocal whether or not seed may be a pathway. But that still leaves well over 100 of these bacterial host combinations where there is no evidence that seed is a pathway, and yet they're still subject to phytosanitary regulations. The International Seed Testing Association has a list that covers 23 non-vegetable hosts, and this is you can see, for one thing, in the non-vegetable crops, the numbers of seed-borne bacteria are lower. They list 34 bacterial host combinations, 15 of which there is evidence that seed is a pathway, and 11 of which seed may or may not be a pathway. So this, I guess the take-home message here is, number one, vegetable crops have a lot more problems with bacterial diseases that can be seed-borne, and also there are many regulations for pathogens where there is really no evidence for seed being a pathway for establishment of the pathogens. And that's just for the bacteria. I could show you similar data for viruses and fungi, but I think that you get the idea. Okay, so when we do have emerging pathogens or changing regulations, or simply have industry needs for new seed health tests, there are a number of different organizations that are involved in developing and validating these methods. And I'll talk in a little bit more detail about these three: ISTA, the ISF ISHI Initiative, and the National Seed Health System. But there are other organizations that also develop and validate methods under IPPC, or the regional plant protection organizations, or the national plant protection organizations. And I'll talk a bit more now about ISTA. And I guess before I do that, I want to kind of bring to your attention that we do have some, I would say, universal criteria that we try to agree on among the different organizations in terms of what constitutes a valid seed health testing method. And those basic characteristics include sensitivity, specificity, repeatability, reproducibility, and robustness. And you can see the explanations of those things on the slide. And the level of sensitivity that's required for a seed health testing method, it varies according to the pathogen. But the important thing is that it needs to be defined for any seed health testing method that's being developed. Specificity obviously also is important, and that one is pretty universal in the sense that we do want every seed health test to be giving us positive results only when we have the true pathogen that we're trying to detect, and not give false positives when we detect something where you detect something that is not the target organism. So these are the criteria that are generally used or universally used, although there are subtle differences in interpretation when various groups will do validation studies. So under ISTA, you have the Seed Health Committee, and there are 2 members from the United States on this committee, including me. The Seed Health Committee under ISTA has an objective to develop and validate methods, but also to do other things like organizing proficiency tests so that accredited laboratories under ISTA can demonstrate that they're able to accurately carry out the methods that they're accredited to do. The Seed Health Committee also organizes workshops and other training opportunities, and does develop the reference pest list that I talked about a couple slides ago. And so if you look at the ISTA website, there's this video, which I'm not going to show you here, that summarizes what the Seed Health Committee does. And you can learn more about proficiency testing and the method validation and other technologies related to seedborne microorganisms on the website. So generally, sort of a thumbnail sketch of how the Seed Health Committee works. Methods are either developed internally by committee members or externally. The process involves proposing a comparative test plan, which is then approved and organized by the Seed Health Committee. And those participants in the comparative test will be labs that may be internal or external to the Seed Health Committee. Mostly they're ISTA accredited labs, but not necessarily always. And after the comparative test is done, the report is submitted to the Seed Health Committee, and we vote on whether to accept those results. And then if those are approved, they're passed on to the ISTA General Assembly for their approval. And then they will appear, that method will appear on the list of ISTA methods on the website. And the procedure is described in this document that I took a screenshot of over there on the right of the slide. So this is a screenshot of the website that where the methods are listed, and there are currently 32 host pathogen combinations with methods that are on the ISTA website. Some of those have more than one alternative, and then there's a link that you can see here also for the pest list. One thing I'll comment on is that there are 32 methods on this page, and you can judge from some of my previous slides that there are many, many more seedborne pathogens than just 32. And so there's a continuous need for new methods because there are many pathogens for which we don't have methods that have been validated and approved by ISTA or other organizations. Another program that I already mentioned is the International Seed Health Initiative, which is under the umbrella of the International Seed Federation. And so this is a bit of information there from their website, but generally speaking, this is an industry group which also has the objective of developing and validating seed health testing methods that are agreed upon, not only among industry participants, but those methods are promoted to be used for phytosanitary certification. And currently the Ishi vegetable group has methods for 33 pathogens. 12 of those are also ISTA methods, and they also have the pest list that I mentioned before, which covers mostly or entirely covers vegetable crops. So again, you can see the number is not that high in terms of all the methods that are out there. And there is significant overlap between the ISTA and Ishi veg methods, but there are also a number of methods that appear under one program, but not the other. And then the next program that I'll talk about that I'm involved with a lot more heavily is the National Seed Health System. As I mentioned, it's a collaboration between APHIS, ASTA, Iowa State University, and the state agents, the state departments of ag. It's been around since 2001. You can see the org chart there on the right. The administrative unit that is shown in the middle of the org chart is the ISU Seed Science Center. It's guided by a Policies and Procedures Board and answers to the accreditation manager at USDA APHIS, which is Sarita Nagy. The Policies and Procedures Board is populated by representatives from the American Seed Trade Association, but also other organizations that are involved in seed testing, as well as the National Plant Board, which consists of the state departments of ag. And Charlie Block and I are the co-directors of the administration unit. So here are the objectives for NSHS. The main one that I'm talking about today is developing standardized seed health testing for laboratory and phytosanitary inspection. We accredit labs to carry out those inspections and testing. Those labs or entities can be public or private organizations. Many of them are seed companies. Others are crop improvement associations. And to say a little bit more about that in the next couple of slides. So we have on our website the methods for 72 host pathogen combinations, and we do, to the extent that we can, harmonize those with both ISTA and Ishi. So many of the methods on our website are ISTA and or Ishi methods, but we also have additional ones that they have not validated. We do offer accreditation not only for seed health testing in the lab, but also for field inspection in the field or greenhouse, sampling for phytosanitary testing, and visual inspection for phytosanitary certification, which is an option that is viable for in some countries for some commodities in lieu of field inspection or lab seed health testing. So those are the accreditation options. We have 26 organizations accredited. 10 of those are private testing labs or inspection services, 10 seed companies, 4 crop improvement associations, and 2 public seed testing labs, including the laboratory here at Iowa State. We have 12 accredited for sampling, 4 for visual inspection, 6 for field inspection, and 13 for laboratory seed health testing. So that's kind of the breakdown of the accreditations, and it affects the whole range of states in the U.S. We do have a heavy concentration of accreditation on the Midwest and the West Coast. The West Coast emphasis has a lot to do with the vegetable seed industry presence there, and then in the Midwest, it's heavily weighted toward corn and soybean inspections and testing, as you might imagine. This is just to indicate the detail to which we have procedures described for doing validation for seed health testing methods. The matrix over there on the right lists those criteria that I talked about before in terms of sensitivity, specificity, etc. And in the matrix, we list the definitions of those criteria and also the expectations for evidence that we expect the validation studies to include in order to demonstrate those criteria have been met. We have an ad hoc peer review system for the validation reports that come in. And then we evaluate those here at the administration unit, and then they are presented, our recommendations are presented to the Policies and Procedures Board, who then vote on whether to accept the results. We have a couple projects underway right now. One is for Stewart's wilt with corn, and one is for bacterial blight in soybean. And we have new projects that are coming up continuously. One last thing I'd like to talk about that is an offshoot of the National Seed Health System is the Seed Health Dashboard. I like to talk about this again as a very successful example of a public-private collaboration to protect seed health. This one specifically targets cucurbit crop seeds that are being imported into the United States, where most of our efforts are directed toward testing seeds that will be exported. So the Seed Health Dashboard, you may have heard of a program prior to this that was called NSHAP. That was the predecessor to the Seed Health Dashboard. And at the bottom of the slide, we have the running totals there under this program. We have collected results on almost 60,000 imported cucurbit seed lots from 34 different countries, and 99.6% of those seed lots were clean for CGMMB. The 0.4% that tested positive are either destroyed or re-exported back to the country of origin. So this has been, I think, an excellent voluntary collaboration with seed companies to protect everybody's best interest in terms of keeping CGMMB out of the United States, where it has been introduced more than once, but it's under eradication, and we are really trying to keep it from being reintroduced. A couple words about Refresh. I don't really have time to explain this program, but this is the regulatory framework for seed health, which is a new approach to regulating seed-borne pathogens that's being developed by APHIS. It's a systems approach that will take into account all the management practices that are involved in reducing the risk of having contaminated seeds. So again, this will be a voluntary accreditation program. But I really just wanted to point out that seed health testing will definitely still be part of this program, even if one of the objectives of Refresh is to move away from testing every single consignment of seeds that are shipped internationally. But there definitely will be seed health testing at critical control points along the seed production and distribution pipeline. So if you have questions about that, I can get into that a little bit more, but just want to point out that seed health testing is here to stay. And just to wrap things up, I think I hope I've made the point that seed health testing is and will continue to be a crucial component of the global seed system. And there are a lot of dynamics going on so that the needs are constantly changing, and we really need everybody working together in order to adapt to the new challenges and the changing needs for seed health testing. And there is this move toward what is referred to as systems approaches like Refresh, which really seek to take advantage or leverage all the quality management practices that are being done within the seed industry, including seed health testing, but much broader than just seed health testing, that all work together to reduce the risk of having contaminated seeds shipped internationally. We'll make one little pitch here for our graduate program. If you want to learn more about this and other aspects of seed technology and the seed industry business practices, we have a graduate program in seed technology and business that I chair, and it's a 100% online program, which really is geared toward seed industry professionals who are looking to advance their careers. And you can contact Laura Youngberg here at the email address, or go to our website, which is seedgrad.iastate.edu. And with that, a few acknowledgements. I mentioned Charlie Block and Sarika Nagy. Kelly Iverson is the National Seed Health System Program Coordinator. And there are several other people here who have helped me with the presentation. So I'll stop there. I've used up my time, and if there's time for any questions, I'd be glad to try to answer those.
Gary, thank you very much for your presentation. Covered a lot of information, but really good overview of the topic of seed health. Thank you so much.
Okay, well, it's been a pleasure, and I hope you guys enjoy the rest of your conference.
Again, thank you, Gary. We're going to transition a little bit here with our next speaker, Virginia Moore. She is a faculty member at Cornell in the plant breeding and genetics. In her lab, she works on a range of species, including forages, cover crops, and perennial grains, focused on breeding for sustainable cropping systems. So Ginny is going to talk to us today about cover crop breeding for the northern US. So please welcome Ginny. We need this switched over.
Okay, great. Well, sorry, I can't join in person today. I just got out of teaching my last class of the semester and couldn't make it up quite in time, but glad to be able to join virtually and share about this topic. As was just mentioned, I work on cover crops among other species, and specifically focused on breeding for New York State and other northern regions in the US. And I probably don't need to tell you all of the benefits of cover crops. I think this group is likely familiar. We know that people have been planting cover crops for a long time for all of these ecosystem service and farm management benefits. But you've been hearing, I imagine, more about cover crops on the policy side lately. There's been new incentive programs that have been passed, and both at federal and state levels, and private sector organizations as well that are incentivizing farmers to plant more cover crops. And I think they're an especially salient management practice, with kind of environmental crises that are ongoing and in a lot of cases accelerating. And this photo in the lower right corner looks like it could be something out of the 1930s, but this is a 2022 image of dust storms in South Dakota and Minnesota happened this year. And we know that cover crops can help with a lot of these major environmental challenges that we're facing. Cover crop adoption in the US has been increasing. So these data are from the 2017 Census of Agriculture by the USDA. We're in the process of doing the 2022 census now, so these numbers will be updated, and I'll be really curious to see what kind of change we've seen over the last 5 years. But in 2017, we had 15.4 million acres of cover crops planted, which represented a 50% increase since the previous ag census. But that's still a drop in the bucket. It's only less than 4% of total cropland acres. So progress is happening, and it feels quick right now, but there's still a long way to go to adopt this practice that is an important tool to mitigate some of these environmental challenges in agriculture. And as farmers are beginning to adopt cover crops on a larger scale. We see that that there's more infrastructure that's being developed to help farmers figure out how to make decisions. That cover cropping is a fairly knowledge-intensive practice, and farmers often struggle to figure out what species they should be planting, at what time of year, at what seeding rate, and many other kind of question marks for them. And this kind of infrastructure exists for other crops at a much larger scale, and we're just now sort of developing these tools to help farmers make decisions in this cover crop space. And there's a huge amount of effort right now among researchers and extensionists and other cover cropping professionals to build these tools and to help farmers make good decisions about cover crops and use them more effectively on their farms. The regional cover crop councils have been a big push on this front, and NRCS as well. And so farmers are increasingly able to make better decisions about species and seeding rates and timing and planting timing and termination timing, all these major decisions, which is huge. But kind of a big gap that still remains is variety information. So cover crop selections are typically made at a species level, and farmers are often planting variety not stated material or some variety that may or may not be adapted to their region, and they often don't have a lot of choices depending on the species that they're planting. We saw in this survey that was conducted by Matt Ryan and some other collaborators of mine around 2015, who did a survey of both organic and conventional farmers about their perspectives on cover crop use, and particularly about the need for improved varieties and more plant breeding investment for cover crops. And farmers clearly want more research to be conducted on breeding and variety improvement for cover crops. And many also agreed that they would grow more cover crops if they had better varieties that were more regionally adapted. And some even agreed that they would pay more for cover crops if they provided more benefits, for example, through improved varieties. So we see that there is a demand, and these results in part motivated the formation of this cover crop breeding network that I am now leading out of Cornell. So that this is a group that formed around 2015, and I got involved as a postdoc and now as a faculty member, so starting in 2018. And this is a network of researchers at universities and at the USDA, both in ARS and NRCS, as well as farmer breeders and other stakeholders that are involved in some way or another in breeding and seed work in agronomy. And the idea with this network is that we're improving multiple different species to be better adapted to the needs of farmers across the country, and we're doing breeding on research stations, on farms, and also testing these varieties that we're developing at a wide range of sites across the US. So we started out mostly focused in the upper Midwest and Northeast, and have expanded really across the country, and our most recent site is at Alaska. That's a new addition this past year. And we're working on a huge number of species, with the main emphasis being on winter annuals. So these are species that are planted in the fall and terminated in the spring. So they're filling that niche between crop harvest and a new crop being planted, very often in row crop systems, but many of these species are also used in vegetable systems and with other cropping systems as well. And we also have a big emphasis on legume cover crops. We know, especially with fertilizer prices, that nitrogen fixation is a really high priority for farmers, and especially in northern regions, which I'll talk about in a minute. We often don't have a lot of legume options that can fit into our crop rotations and survive the winter successfully. So the emphasis, again, winter annuals, legumes, but we also work on cereal rye and on some brassica species as well. And the main breeding focus that we have, or focuses, are high biomass production. We know that more biomass is generally correlated with greater provisioning of those ecosystem services that we care about, that cover crops are providing. We also like cover crops that have good early vigor, stuff that gets out of the ground quickly and can compete with weeds and get a good start before the onset of winter. Winter hardiness, especially at our northern locations. We also select on flowering time, sometimes early and sometimes late, depending on the species and the cropping system context that we're thinking about. For our legumes, we're also interested in nitrogen fixation. And then we have some more species-specific traits that we're looking at as well. And so today I'm focused on the breeding needs for the northern US. As I showed on the map, our network includes researchers across the country developing varieties for lots of species and a wide range of traits. But in New York State and some of the other northern locations in our network, we have some more specific needs. A lot of it is focused on winter survival. So of course, some farmers are interested in cover crops that winter kill for some context that they're working in, but we know that especially fall planted cover crops are going to provide the most benefits if they have the most opportunity to put on biomass before the next crop is planted. So that often involves surviving the winter and growing again in the spring. So we approach this challenge from a wide range of strategies, and so the rest of my presentation will really be focused on how we're doing this in my program and with some of our collaborators at other northern locations. So we want more species that can overwinter, especially legumes. In a lot of our northern sites, rye is really the only cover crop option that's going to survive the winter right now. There are some legumes that survive some of the time, but we don't have really good, consistent legume winter survivors. We want these legumes because of their ability to fix nitrogen and reduce farmer input needs. We also in general know that more diverse cover crop mixtures provide more ecosystem services than a single species alone. So we're looking for more options for farmers. And in our network, we do a lot of selection in the field. In the fall, each year we plant our best material in multiple northern locations across the US and select among the plants that survive. And the main challenge with this method is that winters are unpredictable. So as breeders, we love to see a field like this one. So this is a nursery that we planted in the fall of 2016 on a farm in Wisconsin. And we saw in the spring that fewer than 10% of the plants survived. And so we know that we're really only saving the seed of the most winter hardy plants. And that's great. That's exactly what a breeder wants to see. But for every selection environment that looks like this one, we have 2 to 3 where either everything is surviving or everything is dying, and we can't make good selections for winter survival. So we deal with that challenge in a couple of different ways. So first, we plant many locations to maximize the probability that we're going to have an environment that looks like this one. And so we have our breeding nurseries. So we have a nursery in North Dakota and Minnesota and Wisconsin and here in New York. So those have all been good selection environments for winter survival. But we also do on-farm breeding. And so this is an effort led by Lisa Kissing-Kusik, pictured in the upper right. So she's a collaborator at the the Dairy Forage Research Institute at Madison, Wisconsin. And so she leads this on-farm participatory breeding program where we send our best material to farmers in the upper Midwest, and they make selections on their farms. And another way that we deal with this is through controlled environment testing. So we have a collaborator at the University of Minnesota who has done a lot of this work previously. And so the goal here is to simulate winter conditions in a more controlled way. We can have more predictable outcomes, and we see that the results in the growth chamber, in terms of the material that can survive to the lowest temperatures in the growth chamber, so you can see that in the bottom of the figure here. So this material survives to the lowest temperatures, and in the field, we see that the same material has the highest percent survival at cold locations. And so this work is really promising, I think, to allow us to have more predictable and regular selection that's happening. And I'm really excited that we're going to be soon installing a cold temperature capable growth chamber at Cornell as well. So we'll be able to expand this side of the breeding program here in New York soon. So in addition to developing more species that we can consistently overwinter, we also are interested in identifying varieties that can tolerate later planting and still overwinter and put on biomass in the spring. So we know from our agronomic literature that in general, the earlier you plant cover crops, the better outcomes you have in terms of winter survival and biomass production. But we're interested to see if there's within species variation, if there's some varieties that we can plant later and still have good outcomes. And so one study we're looking at is in winter pea. So this is work led by my graduate student, Raksha Thapa, and she is looking at the optimal winter pea varieties and planting dates for winter survival here in New York, and also with collaborators in Minnesota and North Dakota. So we're planting in zones 3 to 5, and we're looking at 4 different cultivars. And 4 planting dates that fall between late August and mid-October. And pea is a really interesting case here because so in general, what we've seen, especially with the legumes that we work with, is that earlier is better in general. And then a lot of the recommendations that we make to farmers are to plant as early as you can. But with pea, it looks a little different. There's a couple things that are different about peas. They're able to regrow from nodes below ground if they're planted deep enough. So even if the above ground tissue is damaged or dies because of winter kill, potentially if the peas are planted deep enough, and we recommend planting 2 or even 3 inches deep for our pea cover crops, then they can regrow. And so there's potentially a trade-off if they're planted too late. Maybe they don't put on enough biomass and don't do much in the spring. But if they're planted too early, they put on too much biomass and they expend a lot of energy putting on biomass and in the fall, and then all of that tissue above ground dies, especially if the growth habit can change. So when they first start growing, they're growing low to the ground, but then eventually they start growing vertically. And so those early planted peas can see a penalty as well. And so we were interested to look at this and see if there were variety differences, basically. And we have our first year of data now. And so this is kind of hot off the presses. And And we see some interesting patterns here. This is the spring biomass production across the planting dates in New York only. And we see in general that this mid to late September, the intermediate planting dates produce the most biomass in the spring. And there was one variety here, the icicle, that produced fairly poor biomass at all of the dates, so just wasn't a good producer in general. But for the other varieties, we saw improved performance at dates 2 and 3. But with this variety Wyo Winter, we see it really suffered from that earliest planting date. But at the latest planting date, it did significantly better than its counterparts. So maybe there's potential here for this variety, which is a fairly recent release, selected in Wyoming, so selected in harsh winter conditions. Maybe this variety could be planted a little later and still produce adequately. And we're doing some similar work in cereal rye. This project is not, we don't have data from this project yet. We just planted our first year of the experiment this fall. But the study locations are all in New York State, both here in the Ithaca area and also at stations in Canton and Shazy, so more northern parts of the state with harsher winter conditions. We also have 3 on-farm locations. We're testing 6 varieties that have been indicated to be more winter hardy than other material. And we planted up to 4 planting dates, depending on the location, all between late September and early November. Rye can tolerate in general a bit later planting than a lot of our other species. And so it'll be really interesting to see if we have differences in that tolerance to late planting and which varieties are best adapted to New York in general. We don't have a lot of variety trial data on cover crops in general. So stay posted on this one. We also, for the first time this year, have a couple of cereal rye breeding nurseries. This is a fairly new species for our network. Our nurseries this year are in Freeville in the Ithaca area and in St. Paul, Minnesota. And with our nurseries, we're also evaluating, like in the previous experiment, multiple planting dates with the hope that we can identify some rye varieties that are better adapted to late planting. And in general, we're selecting not only for winter survival and late planting tolerance, but in general for early vigor and biomass production and early maturity, especially for farmers interested in no-till production systems using roller crimpers. We also have projects related to allelopathy, so there's a lot of interest in cereal rye having ability to suppress weed seed germination and growth. And we've had some really interesting, promising results on that project, especially with collaborators in North Carolina who are pioneering that work. So in addition to looking at late planting as a strategy to mitigate overwintering challenges, we're also looking at varieties, developing varieties that can be interseeded earlier in the growing season. So the idea here is that rather than waiting until crops are taken off in the fall, we interseed the cover crops in early summer when the corn or other cash crop is still small and the cover crops can grow and establish, and then they kind of hang out under the canopy of the cash crop for weeks or months, and this can be kind of it can be a strategy that allows you to establish earlier and get something in the ground that can then have enough energy and to overwinter. But it can be kind of a stressful environment for the plant. It's shaded, it doesn't have a lot of airflow. There can be issues with disease and lack of light and other, depending on moisture conditions, you might have competition for water, right? So a lot of cover crops are not very well adapted to this environment, and so we're working to change that. So we've done 2 years of testing. We're in our second year of testing red clover varieties specifically for interseeding. Red clover has been found to be more tolerant than a lot of other species to this system, but still performance is a little inconsistent. So we evaluated 11 varieties and we interseeded between rows of corn around the V6 growth stage, which is kind of pushing it to the latest you would want to interseed according to the agronomic literature. That's kind of pushing it is as stressful as possible for the clover, so we can really evaluate how well things do. This is year 1 and 2 fall biomass data. So you can see that in year 1, we do have one variety, Mammoth, that really performed significantly worse than many of the other varieties we tested. But there's pretty wide variation among the top performers. So we don't have a really consistent winner in either year. In year 2, which was a drier year, we generally had slightly lower biomass production across the board, and this variety Alta Swede in general performed worse than the other varieties. In terms of spring biomass, so we're still collecting year 2 data in 2023, but in year 1, we also saw significant differences in biomass across varieties in spring, and particularly a couple of varieties, Alta Swede again and medium red, performed worse than a lot of the other material. So again, we don't have one clear variety that's superior, but we do have some that are not that did not perform well in interseeding. So that's useful information for growers, and we're also making selections now within the populations that had good survival, where we dug up plants from year 1 and are intermating them in the greenhouse to develop cycles of selection to eventually have varieties of red clover that are specifically adapted to interseeding. And then I wanted to talk, this is a seed conference, and I've been talking a lot about cover crops and breeding, but I did want to mention some of the work that we're doing that's specifically focused on cover crop seed. So one big barrier, particularly for legume cover crop use, is that the legume seed is fairly expensive compared to rye and some of the other grass cover crops. And so especially when these cover crops are not consistent in their ability to overwinter and perform well and provide the benefits that farmers are looking for, they're often hesitant to pay a lot for legume seed that if they're not confident it's going to perform well on their farm. And so in all of our nurseries, we are selecting, in addition to biomass production, we're also looking at seed yield and selecting our highest seed yielding families. But we're specifically also looking at vetch bruchid. So hairy vetch is one of the main cover crops we're working on, and it has this seed pest vetch bruchid that has kind of limited management options, especially when we're thinking about organic growers who are big cover crop users. In order to produce vetch seed, there's multiple spraying events that need to happen to produce good seed and avoid this pest issue. So the vetch bruchid shows up in our fields, and it's really ubiquitous. Of course, we see it in the seed production regions in Oregon, but we see it here in New York in our nurseries every year. So it shows up at earliest flowering, and oviposits on the pods, the green pods, and then the larvae infest the vetch seed, and emerge. They have an annual life cycle, so they don't reinfest seed in the field, but we often we don't see the adult bruchids emerging until after seed harvest, and so often people don't know that they have an infestation until it's too late, and we can see up to 90% seed loss without any spray management. And so this has really been a devastating problem in our breeding program. With the first few years before we knew that this was going to be a problem, we had major seed loss and very, very little viable seed from our breeding program. And now we have good management systems, but it remains an added expense for growers and reduces seed quality for those that are not managing for it. And so we starting in about a year ago, we have been evaluating the hairy vetch, our breeding lines and the USDA collection for bruchid resistance. And so that work is ongoing, and we'll also keep you posted on results for that, but we're excited to see where that goes. I think it will have a big impact on cover crop seed production. And I think that's the main summary of the traits that I've wanted to focus on. I don't know that we have time for questions or comments, but I'd love to hear from this group about any other breeding targets that you see would be useful. My program is new and growing, and excited always to get feedback from stakeholders and other researchers. So please reach out if you have ideas about what we should be working on. And I'd just like to acknowledge the various people that contributed to this work. The whole cover crop breeding network, but especially the collaborators I've listed who contributed to the experiments that I discussed today. Also the team that I work with in Northern New York on the rye variety trial, my students that have contributed to these projects, the staff in my lab, and farm staff who have supported this work, as well as the various funding agencies that have supported the lab. Thank you very much for your attention.
Are there any questions for Ginny while we have her up here? All right, Ginny, there are no questions, it looks like. Thank you again for your presentation. It was really interesting to see what you guys are doing down there at Cornell with cover crops as they're kind of growing here in New York and in our region. So with that wraps up our morning session here. I think we have a pretty good lunch planned. So I will hand it over to Alan. And thank you to all of the morning presenters, those who are still on Zoom. We really appreciate it.
I'm really pleased to introduce the next speaker. Molly, most of us know from being at past meetings, she was when we were at Club 86 in 2019, she was on the program there. And at that time, she was formerly the CSO for ABM, which has been acquired by another company. So the new company called Agrauxine, and she's the manager of the North American R&D of that. So the result of that merger, there's now two portfolios for now combined include a yeast-based foliar and soil-applied bionutrition and biocontrol products, along with legacy ABM seed treatment bionutrition products for the large acreage crops. So the focus of the Geneva, New York R&D facility is on supporting the rhizobia products and formulation improvement across product lines. Molly?
Well, I really appreciate, while this is getting loaded, I really appreciate being invited back, because last time I think I forgot my presentation and caused major glitches in the whole program. So, all right. So I'm sharing, I hope, and sorry about this bar here. I don't actually know how to get rid of that, but all right. So again, thank you for the invitation and the nice introduction. Obviously you can see my title. We work on biologicals or microbial based seed treatments and other products in our facility. And Bob Patrick is also here. He's a technician in the group, and together we work on innovation, R&D, and trying to develop new products for seed treatments and foliar sprays, all based on microbes. So this is just kind of an organization of my talk. The introduction part, I'll show you just a couple of marketing slides, and that's just to let you know a little bit about this company that has acquired us and our functions, and it's actually pretty interesting how we fit into the market now. But then, as Alan indicated, we do a lot of work on formulations, and so talking about compatibility with chemistries, between the chemistries and the microbes is a really important part of what we do, and is fundamental to a lot of the forward progress in these types of products. So, okay, this is some marketing stuff. So the Agrauxine is the ag business unit of Asst Yeast. And Asst Yeast is an enormous company that specializes in yeast. They make Red Star yeast. Apparently 1/3 of all loaves of bread baked in the world are made with Asst yeast. So it's a big deal. But Asst, so because their focus is yeast and yeast fermentation, there are a lot of outputs from what they create, not only the dried yeast that you might make in the grocery store, but also the fermentation products and byproducts. And so the rest of these, well, that's pretty small. Okay, so the rest of these areas are also directly related to yeast production. So the baking is obvious. Food, taste, and pleasure, that umami, right? That's what all these business units, Fermentus, Enola, Spider, Springer, they're related to that. Fermentus is in fermentation, as you might guess. So wine, beer, ciders, a lot like what is done here and at AgriTech. The biotechnology areas, and then down here in healthcare, we've got Agrauxine, which is plant healthcare, Filio, which is livestock healthcare, and Gnosis, which is related to human healthcare. So we sit here in the Agrauxine area, and like Alan said, I'm the U.S. R&D manager. We also have R&D operations in Beaucouset, France. So our product line, and I'll talk about more about this later when it comes to how you might classify biological products. There's biocontrol, biostimulants, and bionutrition. And so Agrauxine brought the biocontrol and biostimulation products to our combined company. And then the bionutrition parts, this is where, this is what our former company brought to our total package. And I will discuss all of these more later. But I wanted to give you this background because seed treatments are not, you don't generally think of yeast companies when you think about biological seed treatments or any type of seed treatment. Thinking about the companies that are involved in this area, I'm sure you've all seen something like this before. In fact, I probably showed this the last time I was here, that there are many, many chemical companies, seed companies, biological companies that are involved in seed treatments. And, you know, these are some of the obvious examples. And also it shows how they've merged over the years. So this is a view from 2009, maybe. Then a lot has happened since then. The last time I was in here was 2019. And at that time, the Dow and DuPont had just spun off their ag division into Corteva. But in 2021, UPL, United Phosphorus Labs, which is the largest company in India, not the largest phosphorus company, but the largest company in India. UPL bought Arista, and they became the number 5 out of the, you know, right after the big 4. And then in 2022, Solvay purchased Bayer's seed coating business. And yes, that is the Solvay that we talk about in Syracuse, the Solvay process. It's the same company, also a French company. But all of these companies are chemical companies. And so this is the mix that now my company is a yeast company is playing in. And the difference is that these companies are primarily chemical companies that are used to working in ag. And Asst and Agrauxine are yeast-based and R&D companies that realize they have something really good to offer to agriculture and seed treatments. So now I want to change gears a little bit and talk about the kinds of products that we have. I want to see, I can't really move that. Okay, sorry, I was gonna try and move that bar again, but so how we might classify the different biological products. Oh, that would be great. Thank you. Okay. How we might classify these different products are based, you can do it many ways. It can be based on thank you so much, on the kind of organism that is the active ingredient, but I'm going to classify them based on function because this is how they're regulated. So first I want to talk about bionutrition, and these types of biological products can be, and we're talking about seeds here, applied to the seed, applied to the soil, and then they work with either the microbes that are already present in the soil, they work with nutrients that may be in the soil, and they help those nutrients get into the plant or be more bioavailable to the plant. So there's some pretty obvious examples of those. Trichoderma, Bacillus are well-known, well-documented for their phosphate solubilization. Rhizobia, Bradyrhizobium, Azospirillum, these work to fix atmospheric nitrogen so that the plant can actually take it up and use it. And Rhizobium, Bradyrhizobium, these are endophytes with the plant. Those are the organisms that create the nodules on the roots. And in that way directly supply the plant with functional nitrogen. Azospirillum is a free-living gram-negative bacterium that serves the same purpose, but it doesn't directly, the plant isn't mainlining the results of azospirillum function. The roots need to interact a little bit more closely. So yes, so this, and this is a nice picture of some nice big healthy nodules on a soybean root. So bionutrition products are used very commonly. Most soybeans are either come pre-treated, or it's very common to apply a seed treatment of Rhizobium or Bradyrhizobium to legumes that are planted today, unless you have ground that is naturally rich in Rhizobia. So that's just a good idea. These types of products are also not really regulated as much as other products. Rhizobium, Bradyrhizobium, these are exempt from EPA regulation. Sorry. Okay, another classification is biostimulation. All the same microbes can be used for biostimulation as are used for bionutrition and other uses. But this classification includes those products that increase yields. They might relieve abiotic stress, abiotic stresses like heat stress, drought stress, and they can have effects on flowering time or the resistance of flowers to these abiotic stresses. Trichoderma, Bacillus, these are well known to provide some kind of drought resistance. And where Agrauxine first started its work was on the yeast and yeast fermentation products that were shown to stimulate flowering. So if flowering time is a little bit earlier, maybe you miss the heat of the summer. So so that's one way that they can work. But then these organisms I'm giving are just examples. There are many more examples out there. So this is just a quick list. Other types of biostimulant products might not be living organisms, but maybe byproducts or parts of living organisms. So chitosan is one example. Plant growth regulators, PGRs. These are usually chemical molecules, maybe derived from microbes that can affect plant gene expression or might act as plant hormones and so change how the plants grow. This is a regulated type of product. PGRs, anything that shows this type of stimulation If you make claims of plant growth regulation, the EPA does regulate that. And there are many types of uses. The bionutrition, that classification is mainly thinking about delivering nutrients from the soil, through the soil, from the soil to the plant. Biostimulation can be an application that is either on the seed, or also there are foliar sprays that can also provide this kind of benefit. And the third classification is probably what this group is most interested in, is biocontrols, biological controls. These are the microbes that control disease. So, and again, I've provided a very short list here. There are many others. Trichoderma can provide disease control by many mechanisms. Sometimes trichoderma is a really vigorous soil inhabitant, and so it can outcompete other microbes, and so it just maybe pushes out or replaces the bad actors in the soil. It can directly parasitize other fungi. Antibiosis is a mechanism by which a microbe might produce literally an antibiotic, and so, or a toxin that prevents the growth or kind of pushes down another microbe. And then there's also induction of defense, host defense responses. Bacillus, I think people probably know BT very, very well. Bacillus thuringiensis. These bacillus, generally speaking, produce some kind of toxin that then the insect pests would ingest, and it causes death or extremely slow metabolism. And but there are other mechanisms, not just toxin. They can also produce antibiotics and induce changes in plant gene expression. So and then the yeasts, the kinds of products that come from my company are generally inducing changes in plant gene expression. Obviously, this is a regulated use of these products. These are considered biopesticides, and they are used as seed and soil applications, but also foliar treatments. And then so, but for this conference, thinking about the seed and soil applications, yeah, that is a main use. And one reason why this is so nice is if you provide something that's a biological control on the seed or directly to the soil, then if you're relying on a mechanism where competition or mycoparasitism or something like this is important, that beneficial microbe is right there on the seed where it needs to be when the seed germinates and the roots start to grow. And I would comment, this is also one difference between some of the chemical treatments. Between chemical and biological treatments is some of these biological treatments can become endophytic. And so if they can establish their position on the seed and in the root, then they can stay with the plant throughout the season and provide longer benefits. Okay, so then, right. The next thing I want to talk about is compatibility. So any seed treatment, any treatment that's applied in ag, and you all know this, has to be compatible with everything else that you're applying, especially if you're going to make some kind of tank mix. And so for seed treatments, obviously there is a tank mix, and the considerations are both physical and, in the case of a biological control or microbial product, the biological component, that compatibility is really important. And if there is an issue with the biological compatibility, that is a major problem because it leads to shelf life instability. This is a little bit different from chemical shelf life issues can be accounted for in the formulation process, and it's fairly straightforward because it's a chemical process. But the biology is a little bit different because you do have to account for the aging of the microbe over time. So thinking about chemistry, the role of chemistry in any formulation or in a biological formulation, we have to think about not only the active ingredient, but also the inert ingredients. And I'll describe this in the coming slides. Adjuvants, these are in every chemical product, in every product really, and used in probably all tank mixes. These are spreaders, dispersants, anything to help that mixing or help the efficacy of the product in the end. Polymers, colorants are always present in seed treatments. And then thinking about the co-applied chemicals that might go into a tank mix with a biological. So it's important to note that microbes aren't necessarily susceptible to the active ingredients, right? The bigger issue most of the time is going to be those inactive ingredients. And I'll explain that more in a bit. All right. So all of us like to make analogies when we're trying to understand things. As a vegetarian, I generally think that salad is a really nice thing to make an analogy about. So you get a nice, healthy, delicious looking salad. And what do you want to put in on it? Salad dressing, right? If you get a bottle like this, what's the first thing you're going to do? You're going to check the lid and you're going to shake it. You're going to shake it up and then very quickly take the lid off and pour it on your salad so that it gets on your salad while it's all mixed. So this is one of the biggest things we have to think about when we think about formulation, because if we're mixing different components in that formulation, we have to think about how they interact. This is a good example of something that doesn't really interact. This surface, that surface layer right there, nothing's going on. They can't blend. The other effect that can happen is that you have really good interaction or easy interaction between those layers. And so then the other extreme is that, well, you have good interactions between those layers. However, bad things happen, right? This is a picture of a tank mix where different components to a tank mix have been added. And you can see all this agglomeration. Things have precipitated out and are floating or they're not mixing well. And so all of that, that's probably active ingredient that if you were to spray this or apply it to the seed, it's not going to get on the seed. It won't get out onto your foliar spray and it will probably plug something up and that's bad. So, a lot of what we do in our facility is we think about what's happening at this layer. And so when it comes to making mixing that layer or making mixtures compatible with each other so that they can produce a good uniform solution or formulation, we think about emulsifiers. And not just emulsifiers, we think about the general class of chemicals that are surfactants. So they are active at the surface of these layers, in between the layers, and they can be emulsifiers, dispersants. A lot of these things I think you should be familiar with because you think about how if you're doing a foliar spray, you need to be able to wet and to spread the thing that you're applying. The same is true for seed treatments during the application process, but also it's a fundamental part of any liquid treatment because you're needing to combine things that don't necessarily want to combine. In the example of the salad dressing, well, add a little mustard that works as a really great emulsifier, and you end up with this delicious looking salad dressing, totally uniform, and you can move on. So, but we have to think about, as I said before, it's not necessarily the active ingredients that are causing that cause problems with microbial-based seed treatments. It can be these inactive. And surfactants, these emulsifiers, are things that can definitely cause problems with microbes. So just at the bottom of the screen here, I wanted to show you just a little bit of demonstration that the microbes have membranes and cell walls. But this membrane, we call it a lipid bilayer. It has this structure, with the heads and the tails that align to form this kind of double layer. And that's something that can protect the contents of the cell. The cell might choose to embed some things in this, like proteins or some poor molecules, but surfactants can look a lot like the components of a lipid bilayer, and they can insert themselves into cell membranes. And in the worst case, they can tear holes in the microbial cell membrane and allow toxins to get in, cell contents to get out, and then you end up with something like this, where the whole cell contents have leaked out, or the cell walls have kind of agglutinated together, and it just makes a mess. So this is a tank mix demonstration or example. But when we're working on a formulation for a microbial product, it's really important that we think about not only the microbe that we are trying to formulate, but also about the chemicals that it might be mixed with, and not necessarily the active ingredient, but the inactives, right? They have these huge impacts on our formulations. So when we make a microbial formulation, we have to have these considerations in mind, because, we want to have a uniform liquid. We want to make sure that uniform liquid plays well with other chemicals that it will be used with. We also need to make sure that we take care in how we formulate the microbe so that we can maintain that microbial viability for at least a year. If it's going to be used in a tank mix, and that's almost a certainty, it needs to survive in the tank mix with other chemicals for several hours and potentially several days. If it's a seed treatment, the viability of that microbe needs to have some certain shelf life on the seed. It could be treated a month before it's planted. It could be treated 6 months before it's planted. It just depends on the crop species we're talking about. And then once you've planted it, it needs to be able to survive in the seed and soil environment, and also be able to wake up and grow after having that dormancy period. These are some of the biggest things that we think about as we're forming biologicals, and they are things that as end users are also important for you all or your customers to be thinking about. And I've just listed some things here which I think should be either listed on the label or something to that people should probably know. Doing a jar test to test for compatibility will show you if you've got that mess if that mess in the tank might happen. Your supplier should be able to know if there are any special application instructions. Manufacturers, and this is the last thing I'll say on this slide, the manufacturer of the product itself should be able to give you very good technical help when it comes to how to make an application, or let you know what the fail factors are for the formulation, for the biological product. But in the end, people who are formulating and developing biological seed treatments, they are all working towards being able to use biological products just as you would a chemical product. However, there are certain parts about biology that we just can't get around, and that biological membrane is one of them. All right, so thinking about the future, and I'll try and go a little faster, I guess. Biological seed treatments, there are more and more of them in the market. As you could see from the slides about all the companies previously, there are so many players in this game that have a lot of brain power behind developing these biological products. They will be more and more of an option. And because a lot of them are chemical companies, we can expect that the compatibilities between the biologicals and the chemistries should become more and more commonplace. In fact, there are several examples of of combined biological and chemical products out there already. But we are seeing changes in the field because of the widespread adoption of biological or microbe-based products. And that is that maybe 10 years ago, it was a lot less common for people to be using a microbe on their farm, on their seeds. And so more farms were considered virgin. Like if you hadn't ever used rhizobia before, then you would get an initial burst of a notable performance. But what we've seen as we've been testing around the country over the years is that when we test on farmer fields, because there's already been a lot of addition of beneficial microbes, the differences we see between control and treatment are actually a little less. And this is a lesson for us about how we develop now. The environment that seed treatments are going into now is not naive, as it were, that there are plenty of beneficial microbes and people are taking really nice care of the soils these days. And so as we develop, we need to think about, how do you get performance when you are adding a seed treatment to an environment that already has a lot of beneficial microbes. So it's just kind of a change in thinking that is more recent. Thinking about regulatory aspects, the EPA is continuing to provide a lot of guidance on both microbial and chemical seed treatments. And this is good and bad. However, the products that don't necessarily require regulation are more and more still needing to be evaluated by EPA. So some of the bionutrition products that I talked about, for example, trichoderma. Trichoderma is known to be a biological control. It also provides really nice bionutrition benefits. Some of these dual uses are going to be harder to do. EPA wants to look at all of these and make sure that if you're selling a bionutrition product, that you have eliminated the possibility that it's also a biological control. So that's a fairly recent change that they are paying more attention to these products. As we have already heard, more and more chemicals are being more tightly regulated or even banned. This is true all over the world. And so it's really good news that we're having more biological products because we're going to need something to replace the active ingredients that aren't being so quickly registered anymore. So the thing I would leave you with is a corn rootworm example. So this is a timeline and you can follow along yourself, and I have the reference there at the bottom. But insects are really devious when it comes to evading pretty much any control we throw at them, whether it's chemical or host genetics. So there have been many controls put out there for this pathogen, the corn rootworm beetle and larvae, and over the last many decades, we have seen the introduction of chemistries, the failure of chemistries, the banning of chemistries, even BT, which is biological in origin, but for which the host crops have been, we have transgenic or GMO host crops with the BT toxin in them. Even this has been overcome. And so the biologicals need to be part of this system. And we do need to think about how we deploy any of these technologies. This is one of the worst case scenarios, but there are plenty of pathogens that can show this kind of pattern. So it is a consideration as we develop biologicals, and why we work with chemical companies and seed treaters and everyone we can to provide a holistic kind of or a kind of group think kind of product and process. So that is all I have. I think I'm like -1 in terms of time, but if there are any questions,
Questions for Molly? Yes, sir.
Why would it be a problem for a product to have both control and nutritional benefits?
Yeah. Well, it's not a problem actually, but if you are trying to release a product that you want to be a bionutrition product, but yet it also can control disease, the EPA wants you to register it as a biological control. So, yeah, so it's not an issue. It's only it's an extra regulatory step. And the process for EPA to make that determination is also a PREA action. So that's a minimum 4-month process for EPA to say, yes, we want to regulate it, or no, you're good to go. Yeah.
Molly, thank you very much. So we're going to switch gears and have Margaret Smith give the undergraduate awards. Also,
I'm actually going to wait for like 1 minute because I see all these people fleeing the room, and our undergraduate awardees deserve a good audience. So I'll let people get their coffee, stand up and stretch, and in like 1.5 minutes, we'll do our undergraduate awards. Besides which, Cassidy is leaving and she's supposed to be up here. All right. But that break was to get coffee, but it was also, as usual, to sort out the technology. So thanks for everybody for taking a little break here. I'm Margaret Smith. For those of you who might not know me, I sort of was a backup assistant to Alan for trying to organize the conference today, but I also get the most fun part, which is to recognize our recipients of the New York State Agri-Business Association Seed Committee's Undergraduate Student Award. So each year, the Seed Committee of NYSABA identifies one, or in some cases like this year, 2 undergraduate students who have excelled in fields related to seed and have career interests that somehow tie into seed. So I'm going to be making these presentations jointly with Cassidy. She's sort of representing the agribusiness side and also wearing her hat as a former recipient of the undergraduate award from the NYSABA Seed Committee. So we had the pleasure of having 2 awardees this year. I'm going to start with the one you see on the screen because this is Avery McLean. She is currently in New York City at the New York Produce Show. They have their trade show, so she's exhibiting today, so she was not able to join us. She is an advisee of Steve Reiners, who's one of the vegetable researchers here up at AgriTech. And this is what Steve had to say. Avery is a senior Cal's Ag Sciences student. And one of the things she's doing is during her undergraduate career, she acquired a small plot of land on Grindstone Island, which is up in the Thousand Islands. And she's converting it into a productive small farm to provide fresh produce to about 1,000 summer inhabitants of the island. So you can see this is Avery. That's a little picture of her farm and a description of her farm. She got a small award from Cornell for, oh shoot, I forget what it was called. I forget the name of the award. It's a small cash award to help students who are doing projects related to community support. So Avery is working on this at the same time as she's finishing her undergraduate degree. Steve said she's a unique student that stands out from many in her peer group. He has never met a harder worker. She's been doing a heavy load of classwork, a very intensive schedule of classes that's allowing her to graduate a semester early, maintaining good grades, and at the same time, establishing this farm up in the Thousand Islands. And Steve said she is one of, if not the best undergraduate advisee he has met in his 28 years at Cornell. So that's impressive. Avery sent me this little quote, so I will read it. Usually I ask the student awardee to come up and get their certificate and their award and to say a few words about their future plans. So here's what Avery said about her plans. In 2021, my partner and I started Red Wing Farm, a market garden on Grindstone Island, New York in the St. Lawrence River, to learn about vegetable production, to create a community gathering place, and to increase availability of produce in Jefferson County. My experience starting Red Wing Farm has inspired me to pursue a master's in horticulture and a career in cooperative extension to continue exploring innovative, sustainable management practices and share knowledge with the local agricultural community. So I'll say congratulations to Avery. Let's all channel her sitting there in New York City, exhibiting her produce, and give her a round of applause. And I'll ask Alan now we see the smiling face of Alan Taylor because our second recipient of the award is somebody who was nominated by Alan Taylor and Yu Jiang up here at AgriTech. So I'd like to call on Ethan Lewis to come on up. Ethan is a senior. He's at Hobart and William Smith Colleges here in Geneva. He has been on the dean's list every semester. And he did a summer internship at Cornell AgriTech right here, working in Alan Taylor's lab. So that's what sort of led to this nomination. In the lab, he studied seed coating, pelleting, fillers, and binders. And one of the things that I was told about Ethan is that he was a major in biochemistry, not a bad thing for somebody interested in seed, and had working experience in IT services, so digital technologies. So a really powerful combination. And what Yu Jiang had to say is that he worked on developing new seed coating materials that are compatible with a high resolution fluorescent imaging system that will allow for precision weed management and pest management. So that's a really cool thing. Because he did such a great job there, he was offered a casual hourly position, continuing to work with Alan Taylor, which he is still doing to this day. Ethan, I will say a warm congratulations to you. We have for you also a nice certificate and more importantly, a small check in congratulations. And I'll ask you to say just a few words about your future plans.
Thank you. I didn't find out about this until recently, but it's such an honor to be here with all of you today and to receive this award. I'm sure as a lot of you know, and what I'm going through right now is the PhD application process, most of which were due today. So that's been kind of my life for the past couple of weeks, is applying for PhDs in toxicology. And so I'm interested in molecular toxicology as well as microbiome toxicology, studying the effects of molecular mechanisms of toxins on humans, plants, animals, and also how microbiome diversity relates and affects the response of toxicity in host organisms. So thank you again for having me here today. I look forward to finishing my time here in Geneva and also with Alan, and I wish you all a good conference still.
Okay, we're going to go back to our program. We have two speakers, both coming in remotely. I want to introduce Sam Kluta, serves as a CEO at Canner Earth Science. Since 2007, Canner promotes ideal agriculture by way of innovations to promote both desired yield and environmental stewardship. While Sam was born and raised in South Africa, he immigrated to the United States in 1999 after graduating with his master's degree in accounting science. Once in the US, he worked in banking, real estate, and in 2007, started Canner Earth Science to live out a passion for sustainable and renewable ag practices. Today, Canner has a portfolio of more than 11 provisional and non-provisional patents related to seed treatment, biopesticides, equipment for seed handling and treatment. We welcome Sam and his research team, where they'll provide an overview of needs, challenges, and opportunities related to innovations in agriculture and especially seed treatment. So Sam, I'll let you go ahead and take it away from Georgia.
Well, thank you. And just a sound check, let me know that you can hear me okay. Congratulations to the undergraduate students, Avery and Ethan. It really is encouraging to experience and see a generation of individuals really passionate about community and making a market farm available in their communities. So I'm going to move here to our slides. Hopefully I hit the buttons correctly. When we consider the innovations for agriculture, isn't that a beautiful picture of a light bulb just blowing up with all the electricity? Well, so it can be with innovations for agriculture. And at Canner Earth Science, we experience the complexity of innovations just getting increasingly challenging. There are additional layers of challenges introduced by climate challenges, but also by growers' needs and growers' understandings of what different technologies can do, and a seemingly endless appetite to combine different technologies to push that yield and that genetic yield potential of seed further and further up. If we consider and ask the question, what are climate smart technologies? We debated that at CANAR quite a bit. There are so many definitions of not only climate smart technology, but also what regenerative agriculture may be. And we say simple, you know what, if we can increase our readiness for unusual weather patterns and climate patterns, we are doing well with climate smart technologies. And to that end, we try to find avenues that will allow growers to enjoy one less pass on the field and burn all the diesel and equipment. Or with irrigation, if they can limit the center pivot irrigation system, making one round a growing season, that's a lot of water and energy saved and could contribute to climate smart technologies expressing their value. More on that here in a little bit. Should let you know that CANAR is inviting innovation from as many sources as we can. And we say, when you consider the production of food, feed, fiber, and fuel, it really is amazing how today we get close to that genetic yield potential of seed. But oftentimes it does come at the expense of the environment and the very environment in which crops are cultivated. And as part of our 4F crop security program, we invite in innovation that promotes both the genetic yield potential being achieved and at the same time improving the environment. And that has been CANAR's drive from the proverbial day one back in 2007 when we formed the company. And we find that a number of technical expertise need to come together in one area for that to truly manifest and come to life: yield potential and environmental stewardship. And so not only is it seed applied technology, but also the on-farm expertise. So oftentimes we will work with collaborators or innovators who choose to team with us and find that either one of these extremes may be very well understood, but oftentimes not the combination thereof. And then the agronomy side is very important, organic chemistry, and increasingly the microbial and plant-based solutions are of value to have as a subject matter expert in your team. And out of the 4F crop security program, we noticed that we satisfy a number of the UNO's sustainability goals for 2013. We have them checkboxed over there. We can make these slides available to those who are of interest. So what I look forward to sharing with you here soon is the perspective from an innovative company who are taking technologies to market and who really have their boots on the ground in the farms doing the trial work with growers and hoping to bring real solutions to real problems being technologies that may not work or leave a grower frustrated with not being really scaled up well. Real solutions being where we all sleep well at night, knowing that indeed our technologies offer stronger yield and environmental stewardship. So what's coming, a snapshot of some of the CANAR technologies that may be in different stages of the development pipeline. We're giving you a little bit of a front row seat of what's happening behind the curtain here at CANAR and our innovations for the future. We're all familiar with different types of seed applied technologies: film treatment, encrusting, and pelletizing. Film treatment is hold the pesticides on the seed. Encrusting allows for a little bit of weight gain, and pelletizing usually a round spherical shape, allowing for easier planting. Let's look at some of the film treatment recently in peanuts. The picture on the far left is peanuts applied with the first liquid technology in the United States. For more than 20 years, or as far back as we can know, peanuts have always been applied with a dry material. And it created some challenges related to the flightiness and the dustiness of the chemistries coming off of peanuts. The picture to the left, you can see the plantability being improved by peanuts with a good coating that allows for high degree of slip of the seed. That was a monosem planter planting peanuts. And then when you consider crop protection, the third picture there of also why we need seed treatments. Crop protection protects the peanuts against disease. And we'll talk about the CAN7 technology here in a little bit that helps to overcome some of the phytotoxic effects of pesticides on seed. But why do we need treated seeds? Crop protection, the number one goal, growers will tell you. They need crop protection. But there are some challenges in treating seed. Discussions earlier focused on the biological challenges of seed treatment, but there just is a limited number of fluid ounces that you can apply to any 100 weight of seed. And usually with soybean customers, seldom do they want to go over 5 fluid ounces per 100 weight. Some will challenge 8, maybe go to 10, but it gets to be a little bit of a nail-biting experience for a lot of seed companies going that high. Other challenges of seed treatment relates to pesticide toxicity. Pesticides are great at killing target pests, but unfortunately, as we all know, they also have a phytotoxic effect on the seed. And then over time, resistance can be developed to the very pesticides that once protected the seeds. Build up on equipment is especially a big challenge. Dust or dustiness make a lot of headlines with whenever something is dusty and creating unwanted environmental impact. Flowability of seed regulation, and again, the just sheer sophistication of bringing a seed applied chemistry package together is a challenge. And there are a number of impossibles, and we run into this a surprising number of times. Even just this week, an innovator came to us and spoke to him yesterday, and this innovator was trying to get all the micronutrient demand of the plant as a seed applied technology. And that's my point number 2. So CANR takes the view that there are some challenges and some goals in trying to be climate smart, but you just cannot put on a seed all the amount of copper, as an example, that you need for that crop's growing cycle. The very copper that the plant may need will unfortunately kill off any desired microbes that may be seed applied, as an example. Another impossible, the number 1 there is, we just cannot mitigate the drought risk via seed treatment alone. By the time you have enough water absorbent seed on the seed gets to be pretty big and it just becomes commercially non-viable. So what are some of the strong growing areas that we see in seed treatment? It's definitely biocontrol. Number 1, your insecticides, fungicides, nematicides are globally in high demand, followed by biofertilizers and biostimulants. But surprisingly also, we can talk about all the wonders of climate smart seed applied technologies, but growers also tell us we just have a problem with labor, or we don't have enough water, or our soil is completely destroyed. And we need that fixed before we can invest in even climate smart seed applied technologies. Some opportunities, however, in the United States relate to biopesticides. The United States is the world's biggest market for biopesticides, probably a good 40%, interestingly followed by China. And then you have countries like Argentina, Brazil, Spain, Italy, countries follow. But China, United States is the biggest biopesticide innovator and user. But we see recently from companies like Pivot Bio and others, the gram-positive nitrogen fixers and fertilizer uptake agents and microbes, huge market, and there's a lot of competition coming in there. But our biostimulants or seed applied technologies, even fertilizers, awareness that we pick up on is the need to be microplastic free. And of course, ease of application, liquid or dry. A lot of technologies seem to be geared now not only for upstream seed application, but also for downstream and even on-farm applications. So a lot of technologies are making its way on farm, driven predominantly by the lack of shelf life of a microbe once the package has been opened. It's just not conducive to up or downstream seed application. And then performance matters. And we tongue-in-cheek say, but also appearance. Innovation and the complexity of innovation calls for, once the technology is applied, to also aesthetically look pleasing when you look at the seed. It's an experience that CANR, I don't think, will easily let go of. We've often been told, look, we just want performance of the seed, performance of the yield. We don't care what the seed looks like, only to come later and learn that no matter how good the performance, unless the seed looks beautiful, it's just not going to be work. It's just not going to work. So performance also really matters. Some of the offerings from CANR that we'll jump into here include our broad spectrum crop protection products, our microbial biopesticide K357, and plant-based biopesticides. We'll look at some biostimulants, seed-applied finishers, and some equipment. So let's talk about the K357 patent pending technology from CANR. We believe it's a global first, single-strain, broad-spectrum biopesticide. Now, we mentioned earlier that bioinsecticides and biofungicides are in very high demand. Thirdly, it would be the nematicides. But an increasing growth area is a combination mode of action where you both control insects and fungus, or insect, fungus, and nematodes. There's high demand for that combination type pesticide, one product, multiple modes of actions, multiple types of pests controlled. So we believe we have a global first here in a single strain, yet a very broad spectrum bionematicide in the K357 Bacillus lichen-informis. And it's capable of producing secondary metabolites, chitinase and chitosanase, which degrades the chitin structure or the hydroskeleton of the nematode, larva, adult, or even the egg. And what we're seeing here is a picture of a reniform nematode egg, which was stained red, being surrounded by this Bacillus species, causing the egg cell to lyse. Going on, and now I'm going to just show you some data real quick. Here's an in vitro assay to compare the efficacy of the K357 against the chemical standard Avecta by Syngenta. And 4 different species of phytonematodes were tested: the root knot, soybean cyst, reniform, and the lesion nematodes. And before we went to field, we saw here that the K357 outperformed or matched the control of the chemical nematicide. Here is some University of Arkansas 2018 data that was shared with CANR. And this graph compares the conventional chemistries regarding nematode counts 55 days after emergence and at harvest. And you can see how the cotton harvest with the K357 at 2 fluid ounces is favorably higher compared to the chemistry standards. Here's a real interesting slide. This graph here demonstrates the differences of the nematode counts differences over the growing season, comparing the K357 bionematicide against conventional chemistries. And you notice that the nematode count drops and then goes higher with your abamectin chemistry, that's the solid line. However, with the bionematicide, the nematode counts may not be as low at first when compared to the standard chemistries, but continue, however, to decline and then be even lower closer to harvest. So I don't know if this is technically correct language, but it's kind of interesting to see the proverbial factory in the soil and the bacillus organisms able to expand as the rhizosphere expands. Here we have a very interesting development with a broad spectrum. We have several broad spectrum biopesticides that address both fungi and insects. And we're a very technical company, and one of our products is, as an example, called the yellow biopesticide, just based on the color of the product. And then we attached very, very nice lab project names and numbers to that. But here we have a high standard of making sure that our broad spectrum biopesticides are indeed microbial or plant-based. And we wish to control a number of pests that are devastating to crops. And we have the standard that we only proceed with a broad spectrum biopesticide with known lack of toxicity to bees, avian life, aquatic life, and mammals. And then, of course, it's a bonus if your broad spectrum biopesticide also exhibits biostimulant properties. As an example here of one of our technologies, you can see the zone of inhibition by a industry standard and by one of our biopesticides. This very chemistry with the zone of inhibition plates here were applied to peanuts, and that's on the next slide. And you can see how the performance of conventional chemistry is enhanced with a biopesticide. You see those white spots circled in blue. That's the fungi on even chemically treated peanuts. However, when in combination with our biopesticide formulation, the efficacy of the standard chemistry is enhanced so that there is less of an opportunity for pathogenic fungus to establish. The same chemistry is, we tested on nematodes, and we found on contact kill mode of nematodes here. And the chart here shows different types of nematodes, lesion nematodes, root knot nematode, that just have 100% mortality when brought into contact of our experimental biopesticide. But not only do we see, as an example, fungicidal control, nematode control, but also kingworm or superworm control. And we see that on contact, we have death. We're not going to go into detail on this conversation about the mode of action. That's confidential to each of these chemistries until we're further along with certain patent filings. But we want to show you here real quick what happens. I'm going to see if I can hit play to a kingworm that comes in contact with our biopesticide. And if you're sentimental to a kingworm, this is a tough video to watch. But if you know how much damage they cause to your crops, it's an exciting video to see that on contact, the kingworm dies. So what happens here, the kingworm here takes it up, gets in the system just enough to cause death. And in no time, the kingworm rolls over and jerks with the final throes of death. For us, it's very exciting that a product can kill a kingworm this large and also control a broad spectrum of nematodes and a broad spectrum of fungi. All this within a matter of about 30 seconds. Moving on to the next slide. Let me see. Oh, here we go. No. Going on to the next slide. Field trials. I wanted to share with you, we just started getting field trials back, some even as recent as today. So no chance yet to put them in the slides, but suffice to say that the technology, some of these pesticides that we've presented here today about, have produced significant positive yield responses. This is all good if you have disease control, but unless you see it expressed in a positive yield response, no grower will pay for it. And so we've experienced more than 300 pounds lint per acre produced on cotton, where we've had this yellow biopesticide seed applied. And on other crops in other areas, more than 14% increase in cotton yield, thanks to just this chemistry being applied in combination with current chemistries. So I do want to offer to the team here, if anyone would like to have these slides, even if augmented with our most recent 2022 data, feel free to reach out to us and we'll be happy to make that available to you. Our Microbe 43J is a very, very exciting technology. It's a seed-applied soil inoculant, microbial soil inoculant that we apply on the seed with 2 strains of Bacillus valenciensis. And on the Petri dishes, that can be hard to see from far away. You have different morphology shown, larger dots, smaller dots, if you may, and a dual strain is expressed there. And the auxin production there helps root elongation, especially at first. That is helpful when the crop gets established, but it also assists with phytate solubilization. And it also aids in chelating iron. Let's see what we've made the Microbe 43J look like when seed applied, and coming back to how important appearance may be. So on the left, you have corn seed, and on the right, you have corn seed over-treated with Microbe 43J in one of our slip-shine type technologies. We're coming back to how important appearance is. So now, not only do you have a value enhancement on the seed, but also, again, an appearance enhancement. The slip shine, as the name suggests, also aids slip to the seed and shine in the appearance. In terms of data developed, we've done had more time with the Microbe 43J, and over more than 400 reps, we saw an average of 4 bushels an acre yield increase by just applying the Microbe 43J on corn. There's a little bit of the root structure that shows the benefit of the auxin with root elongation where Microbe 43J is applied. And on soybeans with more than 200 reps, we see a 1.7 bushel an acre increase, 70% consistent. The soy roots there. A number of these technologies are now Slipshine Plus technology, contains the Microbe 43J. It's a little bit further along, managed to get registration in a number of states. So if you're in the upper Northeast and you wish to apply the Microbe 43J as part of your seed treatment offering, ask about the Slipshine Plus 2050. The microbes are in there and allows for superior looking seed with remarkable slip and flow ability. I'm going to talk about POP. So POP is our plant optimized performance or pesticide overload protection. The problem that we have in the market is that a number of pesticides, unfortunately, while they protect the crop, they also offer a little bit of crop establishment drag. And the POP technology, while not yet commercially available, offers to overcome that phytotoxic drag to the seed treated with POP. And we look forward to this year also test the POP technology for overcoming phytotoxic effects of any foliarly applied fungicides, herbicides, or even insecticides. A picture is worth 1,000 words. And so you see on the far left, in the far left tray, corn seed doing really well. It's the control, almost disease-free environment, no pesticides. But the middle tray of corn seed is at 2x chemistry, and you can clearly see the stunting in the germination and early vigor of the seed. On the far right, while it's still 2x chem, we have one of our POP renditions in combination as a seed treatment, and you can see to what a stunning degree the phytotoxic effect of the chemistry is overcome by POP. What we have here is these are soybeans, and you can see how the Untreated control is doing very well. When the chemistry, even at 1x is applied, the soybean growth is stunted slightly. And even with a little bit of POP at half X and then at 1x, the soybean does remarkably well. So we believe POP will be a very, very well received crop establishment tool. Here we have soybeans in the greenhouse, and you can see how they do much better, how the leaves open up and the growth is stronger when the chemistry is applied as a seed treatment in combination with POP. Here we have peanuts. Peanuts do carry quite a heavy dose of fungicides to protect them. And with peanuts, you want them out of the ground so fast, like most crops, but peanuts do well when they lap as fast as possible, when there's no dirt between the peanuts. And so we believe the POP will go a long way to promoting lapping of the peanuts. You can see the difference of the peanuts when POP is applied as a seed treatment. Some more pictures here just shows different types of POP. POP 2, POP 3, we learned that we have different variations of our underlying key components in POP for different seeds. And you can just clearly see the value here of POP. Compare the very bottom with the second from the top, 2x chemistries. And even with 2x chemistries in POP 3, you do very, very well, even better than 1x chemistry on seed. So about CAN 9300, coming back to where technology is applied, and CAN 93 offers to growers the opportunity to apply technology on farm. And here is a number of experiments with different CAN technologies. At the very bottom is without any of the CAN technology, and you can clearly see on cotton how tough the chemistries can be on seed. Cotton is often applied with over 40 fluid ounces per hundredweight of chemistries, easily 2 insecticides and 4 or 5 different fungicides, in addition to talc and pH neutralizers. Effect of corn here. I'm going to pick up a little bit of speed for the sake of time. We've done some germination tray root assays. And we're watching the root length at day 6, and you can see that there's a statistical difference on corn with CAN 9300 applied, in addition to the insecticide fungicide package. Checked also the shoot length. Next picture shows soybean again with different renditions of CAN 9200 and 9300. So 9200 works well on corn, 9300 works well on soy. Going on to CAN 7, this technology is commercially available and registered in most states. We have essential amino acids here and chelated iron, and it's a very, very versatile fertilizer. And applied as a seed treatment, it promotes crop establishment, and when applied foliarly, it helps the plant to allocate extra photosynthetic energy that the CAN 7 provides to where it's most needed. Quick picture here shows soybeans without and with CAN 7 applied at even 1 fluid ounce per hundredweight. CAN 7 on peanuts, very similar to the POP pictures. This shows purely the biostimulant effect of CAN 7, the fertilizers, the states where it's registered. And we're going to briefly talk about slipshine moly, where you're moly deficient or where your soil's pH call for moly. We apply slipshine moly directly on the seed. So you have and enjoy absolute placement of the molybdenum on the seed, allowing your growers to apply any inoculant in furrow. I don't know that we can stand behind this claim, but I will just share with any seed treater that we see increased comfort and adoption of applying inoculant on the seed alongside the slipshine moly. We won't be able to say that your inoculants are safe when applied with slipshine moly. We're not a inoculant major, but we just see increased adoption of both inoculant and slipshine moly on the seed at the same time. Numbers here the states where the slipshine moly is registered for sale. The slipshine line of technologies clearly dry, applied when the seed is tacky, neither wet nor dry. It delivers that slip, shine, and sheen. And in the case of slipshine plus, it delivers the microbe 43J also. Equipment, very key.
I'm sorry, we're running really late here on the presentation, and I hope that people could follow up with you at a later time if necessary.
Sure thing.
So I wanted to introduce the last two speakers from Germain's, and I know both really well. Dale Krolikowski started his career in the research and development of pharmaceutical projects, and then moved into agriculture in 2009, building the R&D department and built the R&D department for Germain's. Currently oversees disinfection of seed-borne pathogens, priming, developing novel seed pellets, and new pesticide protection for soil-borne pathogens. Also with him is Hank Hill. Hank received his PhD at the University of Florida, and then he actually spent 1 year in my lab as a postdoc back in the 80s. He's then been out in the California seed industry ever since, working on a number of different interesting crops and vegetable flower and rangeland restoration for the past 35 years. So I introduce both, and we're going to go right into their presentation on seed technology, enhancement beyond the genetics.
Alan, and
yes.
Thanks everyone for attending today. Hank and I are going to tag team a little bit on this presentation, so bear with us as we get through it. We're taking a different tack. This is really about trying to educate the audience a little bit about seed treatment and seed technology. If you want to know more about Germain's products in specific, you can come to our website or reach out to Hank and I later on. So Germain's, just a little bit of overview, started in Los Angeles in the 1900s. We used to go across the street to this oyster house and have some oysters and beer after work, but you can see our company is right across the street, Germain Seed Technology. So pretty exciting that we've been in business since around 1918, I believe. 150 years of experience. In the 1950s is when we first created the first pellets and focused on the sugar beet industry. We were then purchased in the 1990s by Associated British Foods, and that's who our owner is today. That's a multi-billion-dollar family-owned food company. Compare them to Kraft Foods or something like that. And we were rebranded as Germain Seed Technology in 2010. We talk about a lot of the basic seed technologies. Sam presented a whole bunch of different technologies himself, and I heard him speak a little bit about some of these in general. We're going to get into a little detail about them ourselves. Disinfection, of course, is around removing seed-borne pathogens. We like to follow disinfection with seed health, making sure that we're combining nutrients or biologicals to improve seed growth and development. Seed priming, Hank is going to go into detail about seed priming and how that works. I'll come back around and talk about seed pelleting and film coating and pesticide applications. What's the beauty of seed technology is that you can stack different things together. So we can prime seed, we can remove seed-borne pathogens, we can then put it in a pellet to help it for mechanical plantability. We can add pesticides on the exterior or insecticides to prevent soil-borne pests or other pests from attacking the plant. So it's pretty important for most growers to have a combination of technologies, especially on the vegetable side, which is primarily the market that Germain's drives. Seed health and seed disinfection can be both organic and conventional processes. The goal is to try to not only eradicate the surface pathogens, but really more importantly, to get down into the subsurface seed-borne pathogens. It's pretty easy, as you would guess, to surface sterilize a seed, especially a melon or something like that that's got a smooth seed coat. It's the deeply rooted pathogens that are the difficult ones to tackle. The real goal is to provide seed that's not going to come down and transfer any disease to the plant or transfer pathogens into the soil. There are a lot of obstacles in obtaining clean seed. Eradicating those funguses are much more difficult than bacterial pathogens. And those that live underneath the seed coat or the pericarp are very difficult to eradicate without damaging the seed, as you would guess. One of the other big obstacles around obtaining clean seed is the assays and the testing. There's a lot of good technology around removing pathogens, and then there's really good technology about detecting pathogens on seed through PCR and different techniques like that. And that makes a lot of issues with phytosanitary movement of seed internationally, where somebody believes they've treated seed and has a negative test result, and then an importing country will test the seed through a different method.
Hank, are you there?
Yep, I'm here. Can you hear me?
Okay.
Oh, can you hear
Go ahead,
me?
get up because Dale's connection dropped with us.
Okay, listen, I'm just going to go to my part right now because time is of the essence here. He'll join us back later at the end. Anyway, I want to thank you guys for allowing us to participate in this conference. So with no further ado, I'm going to talk about seed priming. And of course, this has been around for a long time. The best definition that I can come up with is that it's a controlled hydration for a specific time period at a specific moisture content, followed by priming. It's simply controlled hydration for a specific time period, followed by dehydration, resulting in better seed lot performance. And this is an idealized idea of what it looks like here. Let's see if I can, okay. Why do we prime seed? Well, of course, priming primarily results in faster germination and field emergence. Because when seeds are primed, the germination is kind of kick-started. Some processes have just been started, others have been completed. A lot of times, time to germination can be cut in half, and then field emergence is more uniform because germination is more synchronized. And I'll give you an example of this. Here we have an idealized laboratory germination at 20 degrees centigrade. Please note that the prime seed germinates first, a little bit before the non-primed, but more importantly, the rate of germination is steeper. And because of that, you could get more synchronized germination. Like for instance, in this, in 10 hours, 25 to 75% of the seed has germinated, whereas for the non-prime seed, it's closer to 16 hours. The second and most important reason why we prime seeds, and this is really important for a lot of our leafy greens, is that prime seeds prevents dormancy. Priming allows seeds to germinate at higher temperatures than they normally couldn't, and allows seeds to germinate without light when they normally wouldn't. And I'll give you an example of that. Here's primed and non-primed lettuce seeds. The lettuce seeds on your left are primed. The lettuce seeds on your right were not, or I guess it's reversed. But anyway, the lettuce seeds on your right are not. And that's because the environment has induced dormancy. You put these seeds back into a optimal environment, and eventually they'll all germinate, although emergence will be more erratic. In this graph, we show that priming allows seeds to germinate over a wider range of temperatures than non-primed lettuce seeds. And also, seeds maintain their viability even in the dark, whereas non-primed seeds, they lose their dormancy is imposed as the temperature increases, and it's worse in the dark. So it's what I call the double whammy. Okay, I'd like to talk about priming processes. Osmotic priming gets its name. Osmotic priming gets its name because seeds are placed in a solution that osmotically regulates their moisture content. Okay, seed moisture content is high enough for metabolism to occur, but not germination. You know, seeds need oxygen to prime just as they need oxygen to germinate. So a constant replenishment of air is necessary in this method because the solution only holds so much available oxygen. In both hydro and solid matrix priming, a measured amount of water is applied to prevent germination. In hydro, water is applied directly to the seeds, and in solid matrix, water is applied to a mixture of seeds and beneficial materials. And in both instances, because seeds are rotating in a vessel with plenty of air, aeration only needs to be done periodically. Since priming is a process, several variables influence optimal response. Among them, of course, is length of time, moisture content while priming, and then, of course, the priming temperature. For the most part, you can see that too little priming results in suboptimal responses, and too much priming results in a substandard product. For example, this celery variety, the seeds of which were primed at 3 different temperatures for the same amount of time, and then germinated in the light and in the dark at 25 degrees centigrade. The control, the non-prime control is enlisted here because none of the seeds germinated in the light or the dark at 25 degrees centigrade. Evidently, this celery variety is very sensitive. Right now, you can see how different priming at different temperatures influence the expression of germination. And so you really kind of have to pick your poison and just come up with the best overall priming protocol. There are limitations to seed priming. The first and most important limitation, and this is something that I was not aware of when I was working in Al's lab, is that priming not all the time is economically feasible. It adds an extra expense to crop production. And so you got to make sure that the benefits outweigh the cost. Trialing is important, and initial testing is usually done at a no charge to make sure everybody's going to be happy. Priming works best on high quality seeds. And unfortunately, priming shortens shelf life. Germains collects its shelf life data on all priming protocols that we developed. And overall, we found that the priming response is good for 6 to 12 months for most crops. Some crops, like onion, can have a shelf life of less than 3 months. Shelf life of 3 months. But we want to make sure that our customers know this, and that when the seed does come in, they got to go ahead and plant it. My last point about priming is that priming accelerates the rate of germination, but not seedling growth. However, as shown in this slide, faster germination causes seedling growth and photosynthesis to start earlier, which can have a profound effect if time is an issue. This happens, of course, in greenhouse celery, and this is really one of the most dramatic examples of how speed of germination affects subsequent crop growth. I want to make quickly talk about seed quality. You know, I've talked about how important it is prior to priming, but maintaining seed quality after priming and germination is important too. So what I want to do is talk about shelf life. Over time, all seeds lose vigor and viability. You know, I'm sure you've heard, you know, the rate of loss is dependent on the seed moisture content and the storage temperature. And I have alluded before, prime seeds lose viability faster than non-prime seeds. The reason is that priming causes seeds to be more sensitive to moisture content than non-prime seeds. And Al Taylor and I worked on an experiment. It only took us 9 years to publish this, but I want to give you an example why seed moisture is so important. Viability loss. Illustrates viability loss when seeds are rapidly aged. And primed and non-primed seeds were put in two different environments. One environment was a high moisture content environment. Seeds were stored at 9% and at 38 degrees centigrade. The other environment was a low seed moisture content environment, but it had a higher temperature. Please note that for non-prime seeds in either environment, the rate of viability loss is exactly the same. But for prime seeds, seeds stored at 9% moisture content basically lost their viability in half the time that seeds were stored at 6%. So moisture content during storage is extremely important, and we make all our customers aware of that. I'm going to briefly talk about seed pelleting. You know, there's two ways to pellet seed. One is most of the pelleting is done in what we call a vertical plant pan, and the other equipment used for pelleting is a rotary pan. Normally, rotary pans are used for film coating and encrustment and not for pelleting, but you can pellet seeds in a rotary pan. Anyway, this is an example of what the seeds look like while they're going through the rotary pan and being coated with material. Okay, so why do we pellet seeds? You know, pelleting was initially developed to improve plant spacing in the field. For example, because of the small seed size, lettuce was always solid seeded, and the only way to thin to 1 plant per foot was to use a short-handled hoe. For obvious reasons, the use of the short-handled hoe was outlawed in the state of California in the mid-70s. So a way was needed to space plant the seeds in the field. Many schemes were tried, but the use of the Stanhay planter was adopted because it did the best job of spacing out the seeds. The only problem was that the seeds either had to be round or pelleted. Oops. Oh, here we go. Sorry. Please note the holes in this belt. Pellets or round seeds drop into the holes in this belt. The distance between the different holes is going to determine the distance between the seedlings in the field. And this is a cross-section of what the planter looks like. You can see the rotating belt goes around and drops the seed out at a specific distance. The pelleted seeds are held in the hopper. And this is what happens. You can see that the pellets are nicely singulated. In this case, it's every 2 inches. And because they're singulated and spaced out, you can go ahead and thin the plants out with a long-handled hoe. And so currently, this is probably the method used by most growers, but we have have further modernized this process. There is a company that has a automated thinner. The automated thinner goes ahead and using cameras and nitrogen fertilizer to kill the unwanted seedlings. You can get your plants space planted. You can get your 1 plant per foot. What I'd like to do now is talk about film coating and pesticide application. We do quite a bit of this at Germain's. There's many different reasons for doing this. Here are some of the applications. You apply fungicides and you plant insecticides. You coat the seeds with fungicides or insecticides, and you've put a film coating over it to protect the workers and to make sure your pesticides stay on the seed and in the ground instead of the air. Film coating seeds has benefits for the grower. We're looking at film coating with both vegetables and agronomic crops. Film coating film seeds are brightly colored, and this can be used to differentiate what is exactly being planted, so there's no mistakes. For example, you can film coat the onions red for onion varieties that are red. And of course, pesticides can be applied to the seeds and then sealed to protect loss. The interesting thing about this is that with these more aggressive pesticides, a lot of times the seed has got to be pelleted before the pesticide is applied to the pellet, and then it's film coated to keep the pesticide on the pellet. That is my last slide. I want to thank everybody for listening. And do we have any time for questions?
Yeah, Hank, I'll go ahead and open it up. Any questions from the audience?
You want me to turn on my camera?
Yeah, sure, if you want. We want to see what you look like after being at Geneva, Cornell AgriTech now.
Well, you know,
from almost 40 years ago.
Yeah, I know. Let me see if I can get this done here.
Dale's also rejoined us now too.
Okay. Dale, do you want me to shut down my part and then you can continue?
Well,
finished.
We're just, we had too many
go.
glitches this afternoon. We've kind of run out of time. So I really just want to open it up from questions right now.
Can you see me?
No. But it's a beautiful row of trees though.
Okay, there we are, back into the trees. I'm sorry.
Back in the trees. Are we in Europe? Where are we at here?
We're in Ireland.
We're in
Ireland.
Okay.
Yes,
Sam with Canner here with a question. Can you speak a little bit about the degree of germination loss on prime seed? Does it come to a point where it's quickly commercially non-viable to any longer prime the seed? Can you just speak to that a little bit?
Well, this has always been the issue. And the issue with prime seed aging isn't as bad as it was when I first started working in this industry. The use of computers to control inventory has really improved. And so a lot of times, like the automobile industry, orders come in and they're processed right away and sent to the grower in an on-time situation. For the most part, as I said before, prime seed, that the seed that we prime commonly lasts for 6 months to a year. I don't want, because we're working with a lot of different species, I hate to generalize or hate to be more specific than that.
So Sam, I'll jump in a little bit there. There are minimum specifications for incoming raw seed. And as long as the minimum specs, germ specs are in place, there's usually not an issue. I mean, you might see 1 or 2 percentage point drops in germ on some species and some lots, specific lots, but it's not normal. If you're priming seed and you see a 5 or 7 or 8% drop in germination, it's probably not the priming method as much as it's the raw seed quality.
Yeah, that's the other point that Dale brought up that's important. The higher the quality of the seed lot, the better the storability. But a lot of times over the years, we've experienced growers that want this one variety, this one seed lot, and they just want, and they don't care if the viability is 75%. They want to get it planted so that they can increase the amount of seed that they have of this variety. So it's a varietal increase.
Okay. Any other questions? Good. I really want to, and I'm sorry to kind of push this thing through, but we really kind of run over time here this afternoon. I want to thank all this afternoon speakers and everybody that contributed to the success of the seed conference. For those of you that are receiving the DEC credits, hey Hank, they're on, as you go out on the back table, your certificate with your name on. Do not pick up your neighbor's certificate, pick up your own. I've had problems with this before, that's why I'm emphasizing it. Pick up your name on the certificate and have a great trip back. And thank you very much for attending the seed conference.
This has been a production of Cornell University, on the web at cornell.edu.